Making a start. I hope you can actually see me now as well. So good morning, good afternoon, or good evening, depending on which time zone you join us from. So just a second. I need to actually record this as well. So welcome to this webinar, which is part of the EnVeROS project, a project by the Erasmus program of the European Union. My name is Giannis Voghiadzakis. I'm actually a professor at the Open University of Cyprus, professor in environmental conservation, and I'm the coordinator of this two-year Erasmus project, a project on environmental education through roadkill observation systems. I will start with a very brief introduction on the project, and then I will show you perhaps some technicalities. Before I do so, I would like to point out that at this point, the only means of communication through our platform is the chat. So you can write messages in the chat, and myself, my colleague Vasilis and Savas, who are also moderating the conversation, will try to reply. We will give you the opportunity to ask the speakers later on questions either via the chat, or you can turn on your microphones, and I will show you how you can do that in a while. And we're hoping that you will enjoy today's session, and this could be enough time for stimulating discussion. So EnVeROS, as I said earlier on, it's a two-year project, Erasmus project funded by the European Union. And at this point, I would like to start with thanking all those people who made this project possible. Not just Erasmus funding itself, but also the Foundation for the Management of European Lifelong Learning Program at Cyprus, in particular Mrs. Stella Leonidou and Mrs. Polina Stavru. But also at the Open University of Cyprus, my colleague Dr. Βασίλης Λίτσκας, the soul of the project, acting as a project manager for 2.5 years. Ms. Georgia Panagidou was the finance manager, and Ms. Ioanna Sari was our international liaison officer. At the same time, I have to acknowledge the support from the Department of Public Works, and in particular Mrs. Filio Limbura and Mr. Alexis Agustis. As I said, a duration of 2 years, which got an extension due to the COVID pandemic, something we all are familiar by now, and we live with it for almost a year, I suppose. And actually, the webinar we are gathered here today to attend, to contribute, was meant to be a final conference, which obviously couldn't take place. However, the added value of having this webinar, despite the fact that we won't be able to welcome you in Cyprus, in Nicosia, is that more people can join from elsewhere with minimum expenses, essentially, just a commitment of the time. The project partners of this two-year project, in addition to the Open University of Cyprus, who are actually the project coordinators, is Europe Research from the area of Bolzano in North Italy, CDV, the Transport Research Center of the Ministry of Transportation of the Czech Republic, and Terra Cypria, the NGO from from Cyprus. In addition, we had associated partners, as you can see in the slide, both from public authorities and NGOs in the 3 countries involved in the project. I suppose the core issue and the multifaceted, if you want, problem that EnVeROS came to tackle for 2 years, in a way can be pinpointed down to this slide: the Global Roads Inventory Project. In other words, the proliferation of roads, road density, all over the globe. We are all familiar with to biological diversity worldwide. And this is, in a nutshell, if you want, a best and a worst case scenario for animals when they interact or interface with roads. A couple of photos on the left-hand side from Greece and Africa, and the right-hand side less impressive, I suppose, in terms of what sort of animals we're looking at, but equally important, some roadkills from Cyprus. A multifaceted problem which in the last 20 years perhaps has tried to actually bring all the forces possible together as a number of other environmental related issues to tackle, to provide solutions. Researchers, academia on one hand, practitioners on the other, with the important though contribution that society has to play. And all these 3 components, if you want, of this nexus will be discussed in today's webinar. We have invited, and we're pleased to have with us people who actually are at the core of research practice and society interface dealing with citizen science and roadkills. Therefore, the aims of EnVeROS were, and I'm using past tense since the project is coming to an end in a couple of weeks' time, to raise public awareness on the severity of wildlife vehicle collisions, the other name, if you want, the acronym often used for roadkills, mobilize, train, and empower social and environmental groups and relevant stakeholders to directly contribute in scientific research on the WVC subject through citizen science and crowdsourcing, and allow for the development of a public mass movement to combat the issue, of public mass movement to combat the issue of WVCs through the creation of an interactive database. The project itself was built around 5 big intellectual outputs, as they're called in the language of Erasmus, starting with a framework analysis, a needs assessment report, essentially looking at the current stage and state of WVC initiatives in terms of education, mitigation practices, and citizens' awareness. An in-learning course which introduces learners to the key WVC-related aspects following the principles of adult learning and non-formal education. Curriculum, which makes use of the results of intellectual output 2 and provides suggestions for school teachers and for trainers in non-formal education. An online platform and a mobile application which provide a common space where interested groups and users can access the components of the project and interact through the collaborative online tools and mobile applications. And last but not least, a WVC comprehensive replicability e-package, which contains informational, educational material, guidelines, and instructions in order for anyone interested to be able to replicate EnVeROS educational approach in different contexts. I will stop at this point. I would like to give you one more warm welcome, and I will now give the floor to my colleague, Dr. Sava Zotos, who's going to be chairing the first session for today on citizen science. Thank you very much for your attention, and over to you, Sava.
Thank you, Giannis. Hello to everyone. I hope you got me loud and clear. So as Giannis said, I'll try to give my best to chair this Dr. Martin Helliker. Dr. Helliker is now the director of BirdLife Cyprus. He has worked in BirdLife Cyprus for a number of years under a variety of roles since 2004. His particular area of interest is the conservation of farmland birds and, of course, sustainable farming. He has recently completed his PhD in the University of Cyprus and is focusing his efforts on high natural value farmlands and the interaction of grazing with biodiversity. So today, Dr. Helliker is going to give us a presentation, and he's acting as a substitute for Dr. Christina Ioannidou. Actually, Christina was the one preparing the presentation, and she's currently the research coordinator of BirdLife Cyprus. Unfortunately, today he has to attend to an EU workshop on sustainable hunting of the third-term turtle dove, so she won't be able to be with us, but I'm sure that Dr. Martin Helliker is going to give his best presenting what BirdLife Cyprus has done on citizen science. So, Martin, the floor is yours.
Thank you very much, Sava. I hope you can hear me okay. Thank you to the project. Thank you, Sava. Thank you to the project for the invitation. Thank you to Giannis. Helen is a difficult act to follow, and I'm a substitute for Christina, who I'm sure would have done this a lot better than me, but I will do my worst, as they say. Should I share the presentation myself as Helen did? Is that the best system?
No, I think what we did was with Helen was because she had some videos to show. So
okay.
If you don't have videos, I think you can just follow the signs on the screen. That's it.
So I can move it on the screen myself, yeah?
Yeah, by pushing the arrow to the downside of the screen.
Thank you, Sal. I've got it now. Excuse my ignorance. Okay, so yes, I wanted to tell you a little bit about the work involving citizens, so non-experts, though some of them are quite expert, at least as bird watchers, and indeed some of our volunteers also happen to be scientists, but nonetheless, our use of citizen science within BirdLife Cyprus to try and gather information and data that's relevant to our conservation work and our conservation efforts. So a little bit about BirdLife Cyprus. The history goes back quite a way. BirdLife Cyprus was formed through the merger of two pre-existing ornithological societies, the oldest of which started in 1950. These societies were predominantly birdwatching societies, but since 2003, they merged. We formed BirdLife Cyprus. We now have about 500 members, and we now have a staff of 13 people full-time. So we're very big, at least on a Cyprus scale, for a non-governmental organization, and we're the partners of BirdLife International in Cyprus. You can see there what our vision and our mission is. And I'll try to explain how citizen science plays a key part in trying to achieve, in trying to make that mission a reality. So why monitoring? Well, in many ways, Helen has more than covered this already. But why is it important to record species like the olivaceous warbler you see in the picture there? Well, recording species, tracking their populations and numbers and their distribution allows us to have a good idea of the changes that are taking place in our countryside. And birds are generally, though it doesn't always hold true, are generally seen as good indicators of the status of biodiversity as a whole. They're used a lot, and partly that's because there are a lot of bird watchers out there. There's a lot of people who enjoy bird watching, so there's a lot of expertise to tap into, and so it's easier to keep track of birds than it is, for example, of mosquitoes. Kelly knows a lot about mosquitoes, but most people are not able to identify mosquitoes down to species level. So this monitoring allows us to gather information. If we do it right, that can actually be very useful for influencing policy. And this is particularly true for birds for historical reasons. The EU Birds Directive is the oldest of the two European Union nature directives. It's stricter than the Habitats Directive that came along later, so it has a lot of strength in terms of achieving conservation. So obviously in that context, having a good idea of what is happening to birds at the level of a member state, or indeed at the level of the whole European Union, gives us advocacy traction. It puts us in a good position to be able to influence things for conservation. So as BirdLife Cyprus, we hold data and we continue to gather data on the distribution of birds in Cyprus and on their populations and their abundance, and also the habitats they use. And this data is, as I've already indicated, valuable not only for conservation management, but also for the identification of key sites and for lobbying for them to be designated as protected sites, which we've had quite a lot of success in since our formation in 2003, but also with more specific targeted action for conservation. This map here of Cyprus gives you just a quick overview of the coverage of our volunteer-led monitoring schemes. We manage, through cooperation with the Turkish Cypriot Bird Protection Society, Kuşkor, to also cover occupied Cyprus, the area north of the island's dividing line. And the little lines refer to things like our nocturnal monitoring scheme and our roller monitoring schemes, which are driven schemes. So those are surveys that take place along roads, whereas the squares and dots are more targeted in-depth schemes. And I'll tell you a little bit more about those further down. But you can see that it's quite a good coverage of our relatively small island. So what do we cover? Well, our oldest running monitoring scheme is the waterbirds count, which covers something like 50 wetlands, not all the wetlands of the island, but the most important ones for birds. And the key sites are covered every month, and the other ones are covered at least 5 times a year. So that gives us a good database, a good understanding, a good picture, if you like, of what's happening with our wetland birds. Then we have some key sites in Cyprus for the migration of birds of prey, of raptors, like this red-footed falcon you see in the picture here. And those sites in the autumn, when we have the big numbers coming through, are watched systematically. But our biggest scheme is the Common Birds Monitoring Scheme, which involves coverage of kilometre squares and a big team of volunteers, and that's been running systematically since 2006. And we've also done, as part of that Common Birds, but also expanding it to a scale of 10 by 10 kilometre squares across the whole island, some work on atlasing, which has been included in the recently published new European Breeding Birds Atlas. Cyprus was not in the last publication, but we are in it this time, which is good news. Then we have some specific surveys which target specific birds that are just not picked up with our other monitoring schemes. So things like owls, like the Cyprus scops owl you see in the picture here, stone curlews and nightjars, which require nighttime surveys because they're nocturnal species. Those are done along driven transects by volunteers. And then key species like the European roller, which is a species with an unfavorable conservation status, for which Cyprus holds a very important population. So again, we do driven transects in the late summer to keep tabs on what's happening with our breeding population of European rollers. In cooperation with Kuşgor, every year, in May every year, we do a boat survey of the Glides Islands off the very northeast tip of the Carpathia Peninsula in Cyprus, because those islands hold the only breeding colony of the Ordwin's gull that you see in the picture there in Cyprus, but also the most important breeding concentrations of the yellow-legged gull and the Mediterranean shag. And then, of course, we carry out specific monitoring for our most threatened species, which is the griffon vulture. And this was done under the YIBAS project, funded by Interreg between 2011 and 14, and is currently continuing under the Life with Vultures project, which is trying to save that species by focusing in particular on the very difficult problem of illegal poisoning through use of poison baits in our countryside. A little bit more about why we do this monitoring and what we use the data gathered by our volunteers for. Well, BirdLife International produces the European Red List of birds. It produces the update on the conservation status of the birds of Europe and the rest of the world, from our point of view of Europe, so we contribute to that. I already mentioned the recently published, earlier this week actually, European Breeding Bird Atlas 2. Cyprus is in it this year. That gives the breeding distributions of all the birds in Europe. Very interesting patterns come out of that compared to the last atlas 20 years ago, largely due to climate change, we might suggest. And then our data also forms part of what Cyprus sends to the European Union under the official reporting processes under the Birds Directive. So member states have to report, and we contribute a lot of that data so that the EU can keep a check on how well or not so well member states are implementing and enforcing the Birds Directive. These are two key wetlands in Cyprus. The one on the left is Orokleni Marsh, which was designated as a protected area under the Natura 2000 network, thanks to the data that we collected as BirdLife Cyprus. And that was the subject of a life-funded project a few years back, a very successful one for the management of that site. And then on the right is Agrotiri Marsh, again, a site that we monitor very regularly and have done for decades now. And that was the subject of a Darwin-funded program. For both of these, the data that have been gathered through citizen science projects was crucial, both in designing the actions in those projects and also in monitoring after the actions to see how effective long-term those actions have been. I'm happy to be able to say that in both those cases, the actions that were taken during the projects have continued to be very effective in terms of biodiversity management and conservation. But we also focus on the vulture that I've already mentioned on the right, so data on that is important. And then on the left is the barn owl. We have a program that our nocturnal monitoring scheme has contributed key data for. It's not actually, strictly speaking, a program for the conservation of the species, but rather a program for the use of the barn owl as a natural predator of rodents in an effort to stop farmers and hunters and communities in general from using so much dangerous rodenticide. And the thing that is particularly important to us, it's less science, it's quasi-scientific, it's based on science, but it's about communication, is that this data is absolutely key in terms of the advocacy we do as an organization. So in terms of our efforts, successful or otherwise, to try and influence decision makers for better conservation action, more effective biodiversity protection in Cyprus. I think it goes without saying that if we didn't have this wealth of data accumulated over years, then our opinions would be even less listened to. How do we do this? Well, there is, to start with, Christina wanted me to emphasize that there's just no way we'd be able to achieve the coverage we do achieve if we didn't have the contribution of our bird monitoring volunteers. 90% of the work we do in terms of monitoring is done by volunteers. There's a picture of Christina there in the field. Key to this, and this is something that Helen also referred to in greater detail, is having standardized protocols and training volunteers in that, which is quite an investment of time for the office staff. It's well worth the investment 90% of the time. Of course, you have volunteers who don't quite make the mark, and then you have that slightly awkward situation of how do you, I won't say get rid of, but how do you discourage those volunteers from continued participation? But 9 out of 10 of our volunteers, on average, get that you need to have a standardized protocol, get that you need to have training, and more importantly, they understand that you need to continue following that protocol if the data you're collecting is going to be useful and reliable and not disputed by the powers that be. There are certainly a lot of challenges in setting up citizen-led schemes. You have the gold standard of the best possible methodology you could use in the field. And often the reality is that you have to pull a little bit back from that because you're not working with trained scientists. You're working with enthusiastic and capable volunteers instead. So once you accept that, and that in a sense is a lesson we've had to learn the last few years at BirdLife Cyprus, once you accept the limitations that are inherent in working with volunteers, then you can still, sorry, was that a question or? No, I'll continue. So standardization is absolutely key and not being too ideal. Now, the situation with birds is perhaps a little bit easier than it is with other groups. As I said before, BirdLife Cyprus has its roots in bird watching. So in a sense, we already had a ready group of trained people for surveying, or at least they were self-trained or collectively trained in identifying birds, but that doesn't always translate into being trained for monitoring. So you have to guide people away from pure bird watching to actual targeted survey work, which is not to suggest that the bird watching records, which we gather and have gathered since the 1950s as an organization, are not invaluable in themselves. In fact, if we go back before 2005, that is the only data we have for Cyprus. So it's still very useful data, but it still doesn't have, of course, the quality that systematically gathered data does. It's important to carry out workshops, to have regular contact with volunteers, to encourage them, to give them feedback, to answer their queries, to give them an opportunity to input into the effort and to adjust things sometimes. There are times when we have actually changed the way we do things a little bit because of input from participating volunteers. But it's also important to remember that actually running a volunteer scheme isn't free. There are costs incurred in terms of having to cover people's fuel and transport, especially if they're doing surveys in more remote areas. There are costs for workshops, there are costs for equipment, and there's also a big investment involved in terms of time of people coordinating the volunteers, making sure that it's all running smoothly, and then collating and analyzing the data. So it's not a free ticket to monitoring. The ideal volunteer, well, we never have the ideal volunteer, but we're lucky in the sense that we have a lot of expert bird watchers with a lot of ability, a lot of people who are committed and 9 times out of 10 reliable. And ideally, a good volunteer is also able to speak efficiently and effectively about what he's doing, why he's doing it, and pass that message. Helen really brought that to the fore, the importance of these schemes as communication to the public at large about the importance of monitoring and the importance of conservation. We do, though, have major challenges in Cyprus in terms of volunteers going forward. The truth is that most of our volunteers currently in our team are of a certain age and above, and we want to change that. We also want to engage more local volunteers, not to be so reliant on expatriates working in Cyprus. So I wanted to wrap up by talking about our bird ID course. This is a new initiative we launched this year. It's been a little bit affected, like everything else, by COVID, and it's still in the pilot or trial phase. But the aim here is to build small teams of interested, enthusiastic people, like the people in the picture there, who are not yet at the standard of recording, bird watching that we need for surveys, but to get them to that standard. The idea is to have a very structured system and to roll it out year on year in order to build a stronger team of, in particular, younger and more local volunteers. I think that's all I had to say, yes, but Sava, I also wanted to share just one slide, if I may, of some results.
Yes,
if I,
of course. Yes. You can share your screen if it's not on the presentation.
Yeah, it's not in the presentation.
Okay.
So for sharing the screen, I have to go to the
down right side.
Yep.
There is this pink colored
arrow sort of thing.
Arrow, okay, yeah. You can choose share content. It's the third
share content.
Symbol.
Okay.
Yeah. The second
oh
sign.
yes, the screen.
Okay, yes, you found it, and then just click on share your entire screen and click share.
Share entire screen. Yeah, I got that far, Sava, but then it stopped.
Okay.
Share entire screen.
Well, if you push the button on the screen, you see a small reflection of your screen. If you push your button on that, then the share button will become colored. Okay, that's it. You've done it.
Right. Can you now see?
Yes, we can.
A chart from Bird Census News. Okay. Well, this was just to wrap up and to show that all this effort by our volunteers does result in actual useful data. This is a publication by Christina and myself, based entirely on volunteer data in Bird Census News a few years back, and this is the trend in common birds in Cyprus. So the solid line is what we classify as common breeding birds, 40 species, and then it's also broken down into farmland birds and forest birds. So this is really useful data to see what's happening to those populations, and it also gives us an indication to what's happening to those habitats. And you can see the ups and downs in that are probably attributable to variations in rainfall, which are very important in Cyprus. But what's also interesting is that you can see the farmland birds as a subgroup are in a worse situation than the common birds or the forest birds, which is in keeping with the pattern for the rest of Europe and the European Union. Something is going wrong with our farmland ecosystems, which lots of data and lots of research suggests is due to intensification farming or over farming, if you like. That was it. Thank you very much for your attention.
Thank you, Martin, for this really thorough presentation on the work the BirdLife Cyprus is doing on monitoring the birds of the island, using, of course, the assistance of the volunteers in this citizen science approach. So do we have, I think we have time for a couple of questions. As previously, you can raise your hand, or you can just write down the question on the chat. Yes, we have a question from Giannis.
Yes, so Giannis is asking my opinion on data access for data resulting from citizen. Yeah, that's a very interesting question, Yanni, and a very important one. I think this data has to be open access, doesn't it? And I think going forward, it's important that we all share data as much as we can. At the moment, as BirdLife Cyprus, we have a data sharing policy, and the only people, or the only applicants, if you like, the only people who ask for data where we won't give it free is where this is where a request comes from a developer. Not because we think the developers shouldn't have the data, but because this is obviously a commercial undertaking. So we think it's right that they should contribute something towards our effort to gather that data. So we ask for something to cover our costs. But in every other case, you know, if it's researchers, for example, or someone just interested in the general public, we try and make it accessible to all. And we publish things on a monthly basis and on an annual basis because of that conviction that it is important that everyone has that data.
Thank you, Martin. Do you have any other question? Okay, then allow me to ask a question, Martin, because it was very interesting what you said about the network of volunteers and the protocols that you're designing, and how difficult this is for the office, yeah, and to have a sustainable operation there and training, yeah, the volunteers. I haven't, perhaps I misunderstood, but I have seen that you have everything on protocols and you don't have an application, or is that correct, or I have misunderstood?
No, you're absolutely right, Sava, and I was impressed with what Helen was showing before with the Ladybird application. In fact, I was trying to download it while she was talking about it. And I know that a lot of partners in the BirdLife family have done some amazing work with applications that allow people to record birds as they go along in the countryside with incredible detail, and that can add a lot in terms of what you can get out of that data. It's the same as with a lot of things, Savo. We need to find a source of funding in order to do it, but we would love to do that.
Can't agree more. Yes.
Yeah, I mean, and you know that very well. You know, all these things are funding dependent, but I think that is the direction to go in, and it's definitely something we need to do. I think the days of recording everything on paper and then having to transcribe it, yeah, we need to move on to that. So as soon as we find a nice source of funding, we will definitely try and do that.
Okay, thank you, Martin. I have several questions, but I'm going to keep it for later on because we're running out of time. And we're going to move to our next speaker, Mr. Chrysostomos Galanos. Mr. Galanos has completed his bachelor study. We have some noise there.
Yes, hello, can you hear me?
Yes, Chrysostomos, is that noise coming from your end?
It's a noise.
It's a noise. I can hear a loud noise. I don't know if
I don't know if
can
I'm.
you hear the noise too, or is... No, I think it was Mr. Galano's mic.
It's possible that it's the how it's called, the ventilator of the laptop.
Perhaps. I think we can bear it. So
but
let me
if you give me,
okay. Yes.
If you give me 2 minutes, I will try to access from another computer. Maybe it will be better. Do I have 2 minutes, or it's bearable like that?
I think it's okay. I think it's okay to leave it as it is now, and let's move forward because we're already behind schedule. So to introduce our next speaker, Mr. Galanos has completed his bachelor studies on business administration and continued with the master program at the Mediterranean Economic Institute on Hanya. The subject of his thesis was the environmental citizen science in Greece and the perception and attitudes of the key actors there. Currently, he's a master student in the Hellenic Open University, and at the same moment, he's working at Hanya as a consultant regarding social and solidarity economy. He has involved in many projects relevant to social and solidarity economy, and I'm sure that part of those projects is going to present it today. So, Chrysostome, we're going to open your mic. Please proceed. We are really apologizing for this small noise, but let's see how this goes, okay?
Yes, now you can hear me.
Yes, you can proceed. Loud and clear.
Okay. Sorry for the noise. I hope it's bearable. First of all, I would like to thank you all for this invitation, and especially Professor Voghiatzakis. Right now, I'm talking to you from Hania, where I live for the past 5 years. One of the reasons that I moved to Hania from Athens, it was that I followed this master program in Mediterranean Agronomic Institute of Hania, and specifically it was in the Department of Geoformation in Environmental Management. And the subject of my thesis, it was environmental citizen science in Greece, perceptions and attitudes of the key actors. And Professor Voghiatzakis was my supervisor. So today I will present to you shortly the main results of this research. So first of all, when we talk about the key actors of this research, we divided our target group. It was 3 main parts. It was people, employees, and representatives from environmental non-governmental organizations, scientists, environmental scientists that they are working on research centers or higher educational institutions, and they have a motivation to collect environmental data. And then we had civil servants in services like the Ministry of Environment, that their work is related with environmental conservation. So what we had, it was out of this target group, we had 178 fully completed questionnaires, and the proportions among the 3 groups that I mentioned, something like a half of the questionnaires came from the public sector, something like 3 out of 10, 30% from researchers, and about 20% from the environmental NGOs, from employees or representatives from environmental NGOs. So what specifically were our research questions for this study? First of all, we wanted to understand to what extent the actors in Greece they were familiar with the term of citizen science, or in general with the concept of this practice of citizen science. What it was the attitude towards the phenomenon, of this phenomenon, it was if they were positive or negative towards the citizen science phenomenon. We wanted to understand what are the main obstacles to the development of citizen science in Greece, main reasons for the reduced visibility of the term in Greece, and lastly, we wanted to understand what were the significant differences between these three groups of factors. I wanted to say that question number 4 we added after we received the first questionnaires, because our main hypothesis in the beginning of the study, it was actually that the citizen science phenomenon, it was barely not in existence in Greece, and this was due to a desktop study that this study became, a desktop study that I did, and we couldn't find so many projects or published papers from Greece about citizen science. But when we started to receive the first questionnaires and we did the first analysis, we saw that the reality in the field it was not exactly like that. So then we added this fourth research question that it was done with semi-structured interviews. It was a quality part of this study to understand what was happening over there. So regarding the first research question about the familiarity of the actors with citizen science, we had a percentage of 40%, a proportion of 40% that they knew the term. This was all the responders. Now, if we see, and I hope you can see this figure, per group, we can understand a little bit better the reality among the actors in Greece. And the reality was that the representatives from NGOs and the researchers, they were quite familiar. The researchers, they were the most familiar of the three groups. Something like 70% knew the term of citizen science. But also the people from NGO, around 50% knew the term. And you see that the situation is different in public sector, where about 80% participants in the survey, they didn't know the term. Concerning familiarity, we wanted to understand what is happening not only with the term, but also with the concept. So we had another question in the survey, where we were asking the participants if they knew any of the following terms that they were close with the concept of citizen science, like public participation in scientific research, or community-based environmental monitoring, crowdsourcing, volunteered geographic information. So here we see that first of all, what we understand is that there are some terms that which terms are popular among the actors in Greece, and the most popular term, as we can observe, is public participation in scientific research, which is a term that almost 50% of the participants they knew. Now, this is per group, and I think it's obvious this trend that we saw before. The light green is the NGO, the green in the middle, if you can't see the figure because it's small, are public bodies, and then the dark green are the researchers. So we see the term that the trend that the people from NGOs and the researchers, they know the similar terms and not so much the public sector. That is not so surprisingly. What I think that is quite interesting in this figure is the last column, where we have the question, none of the above. Do you know any of the following terms? None of the above. So there, I think it's interesting if we see the column for the public bodies, that around 50%, as we can see, they were familiar with the concept. And I think this is interesting because even if, as we saw in the previous slide here, the public bodies, they don't know the term of citizen science, something like 80%, anyways, they know the concept, they can understand the concept 1 out of 2. And I think this is interesting. For example, in situations that we want to approach public sector to promote this kind of practice, for example. So it's more easy to, if we know what term to use. Okay. So now, regarding research question 2 about the attitude of the actors towards citizen science. We had the Likert scale within the survey with 18 statements. Statements such as citizen science can support the collection of environmental data on a large geographical scale, or citizen science can support government agencies in collecting environmental data as a cost-effective alternative, and this kind of statements. So the participants could say if they agree a lot, at all, a little bit, or a few. And there we had some points, and we could we have the result in a scale from 0 to 100, that all the responders, they were positive, they had a positive attitude towards citizen science, around 65 points out of 100. And then we see per group that the people within environmental NGOs are the most positive to run citizen science projects, or that they believe that citizen science can be of help, about 75 points out of 100. Then the researchers are the most positive out of these three groups with 65 points. And then the public, around 60 points out of 100, that is more than 50 points. So they were the result, I think the meaning is that even in the public, the main percentage is positive towards this phenomenon. Regarding the same research question, we had another more straightforward question in the survey. Do you think that the citizen science program will offer something positive to your organization's activity or to the research you are conducting? And here the percentages are more clear. From all the participants, yes, they answered around 75%. It was a very small proportion that they said no, only 6.7. And then we had I don't know, I don't answer, around 70%. And this is absolutely understandable, because this is, as we can see here, group, this is the proportion that comes from the public body. Here is the same question per group. We see that NGOs and researchers are very positive, with something like 90%. And then the public bodies, it's not that they are not positive. Actually, they are positive, something like 65%. But the thing is that they say that they don't know, because, as we saw before, there is a big part of this sector that they don't know the term, something like 25%. So there is a big I think there's a big opportunity to promote this phenomenon in this part. I go on, I proceed. This question is about the main obstacles for the development of citizen science in Greece. Here, I think we had a big consent among the participants. As we can see, the five main obstacles are the same for all the groups. And first, by far, and not surprisingly for those that they know Greek history and Greek situation, first by far, the obstacle that was answered was lack of cooperation culture, with something like near to 60% of answers. Then it was ignorance of the existence of the phenomenon as a second main obstacle, lack of know-how as third, low levels of trust from citizens to the institutions, and lack of incentives on the part of citizens. What I think is of interest in this slide is if we see the main obstacles that they are important per group. For example, in the public, fourth main obstacle, it's internal issues of organizational nature. And this, I think, it can be understandable if we think about bureaucracy in public sector. And for example, only public, we have as a main obstacle with a big percentage, 25%, insufficient legal framework. As we know, public bodies, they are a little bit more tolerant when they have to deal with laws and this kind of regulations. So I'll go on. Or, for example, for the researchers, we see that main problem is typical requirements of specific data collection protocols. That is quite also, it makes logic. Main reasons for the reduced visibility of citizen science in Greece, those things came out of semi-structured interviews, as I told. The main reasons that they came up, it was that the researchers that participate in citizen science projects often do not publish due to data quality issues, and this was in relevance with the literature. Also, here we confirm it in Greek reality. Second issue, it was that NGOs that they run citizen science projects, often they don't publish in scientific journals, so the projects are not visible. Then, and it was mentioned in the previous presentation, a lot of projects, they terminate after the completion of their founded projects, sometimes within European projects, programs. So when the fund finish, the projects they can't continue. So they don't have the time to diffuse in the society. And lastly, it's very common that the term of citizen science is not used. That relevant projects they run, and for example, the Hellenic Ornithological Society runs big projects that they are citizen science projects, but they don't use the term. So in my desk of study, I could not find them, for example. And regarding the last question we had for our study, the significant differences between the actors, we see that statistically, the main differences are between, and it was obvious, and we expected that, it was between the public and the other two groups of the actors, the environmental NGOs and the researchers. In all the categories about the term, the familiarity with the term, the concept or the practice, the statistically difference, it was between the public sector with the other two groups. So, a small summary of findings. The first, it was regarding the familiarity. We saw that the actors, they know the term at the end, something like 40%, and about 65% knew the concept. And this was in contradiction with our initial hypothesis. Key finding number 2, we saw that the actors are positive towards this phenomenon. Number 3, the 3 main obstacles that I mentioned before, first and by far, lack of cooperation culture, ignorance of the existence of the phenomenon, and lack of know-how. Maybe Professor Roy could help us with the know-how. Key finding 4, the 3 basic reasons for the reduced visibility is the underrepresentation in the formal literature, talking about Greece. Relevant projects employ different terms to present themselves, and then there's no promotion or problematic promotion of this kind of projects. And lastly, the 3 groups, they had, as I told, significant differences, and especially between the group of public and the other 2 groups of environmental NGOs and the researchers. And the most contradictory pair concerning the attitude towards citizen science was environmental NGOs with public servants, even if, as we saw, as I told before, even if public sector is positive, has a positive attitude towards the phenomenon. That's all. Thanks a lot. If someone wants to contact me, here is my mail. And thanks for your attention.
Thank you, Chrysostome, for this very interesting presentation and the information you share with the team on the perception of key actors in Greece. Very interesting indeed. From my side, I was impressed by the results you have on the obstacles that each group is facing towards citizen science. Because we're a bit behind time, when we're running late, we're not going to go to any kind of questions now, but please keep all the questions you have for Mr. Galanos, and we can discuss it at the end of today's sessions. And we're going to proceed to our next speaker, Mrs. Eli Chikali. Eli is currently working as a researcher in the Terrestrial Ecosystem Management Lab at the Open University of Cyprus. And she's a PhD candidate in the Department of Biological Application and Technology at the University of Ioannina, Greece. She has published scientific articles concerning butterfly conservation and participated in various research groups in Greece and Cyprus. She is also co-chair of the Cyprus Butterfly Study Group, a group that is doing tremendous work on collecting information on butterflies in Cyprus. Please, Eli, the floor is yours.
Thank you, Sava, and thank you for the invitation. I'm going to be brief. I'm going to say to get you through the first steps on the butterfly monitoring in Cyprus. So why monitor insects? They have been documented insect declines in recent years, and these declines are documented across a variety of group of insects, including butterflies, and it was all over the media not long ago. Insects are usually overlooked, they are ignored, but they're very important for ecosystem services. They are pollinators, predators, decomposers, soil engineers, and simply food for other animals. They outrank all other animals in terms of species numbers and biomass, but there are very few long-term studies on insect populations. So why monitor butterflies? Butterflies are the best monitored insect in the world. They are very well documented and very popular to the general public. They're relatively easy to observe. They are ideal indicators, and they are very measurable. They are very sensitive to environmental change. They occur in a variety of habitat types, and we can use them as surrogates for other insects. Cyprus has a quite high number of species compared to other Mediterranean islands, 53. We have 6 endemic and subendemic species, and we have 2 that are in the IUCN Red List of species. The butterfly study in Cyprus, the research started in 1955 with the first list of Cyprus butterflies, and then we had several publications followed in the 19th century. We had the first reliable list in 1983, and then we had the book by Christodoulos Makris in 2003 for the butterflies of Cyprus. And from that onwards, we had also many articles in peer-reviewed journals, and the latest one is in 2016. In order to protect and conserve butterflies, we created the Cyprus Butterfly Study Group in February 2012. The aim is to promote the study and conservation of butterflies on the island. And the group is a partner of Butterfly Conservation of Europe, which aims to halt the decline of butterflies in Europe and their habitats. As a group, we run a recording scheme. We produce monthly phonograms, we have a newsletter, we attend meetings and workshops in Europe, and we publish our research work. The recording scheme was established in 2000 to collect data on butterfly distribution. And until now, there are 293 contributors. The data that are collected by the volunteers are, you can see the production, we can use them to produce a distribution map like this, but these data are opportunistic, they are not systematically collected. So we have sightings across the island using the recording scheme that we have, but we need more robust data that we can use for analyzing butterfly trends, and we need to collect them systematically. So to do that, we need to establish a butterfly monitoring scheme. Butterfly monitoring schemes in Europe started a long time ago. In 1976, the first one started in the UK using transects, and the Netherlands was the second country to start butterfly monitoring in the 1990s. And many European countries followed, like Belgium, Spain, Germany. And also in 2014, the European Butterfly Monitoring Scheme was created by Butterfly Conservation Europe with the help of the Centre for Hydrology and Ecology in the UK. Now, a project started 2 years ago, in 2019, in December. It's called ABLE project, which is the title is the Assessing Butterflies in Europe project. And the main task of this project that we as the Cyprus Butterfly Study Group participate was to develop a butterfly monitoring scheme, and basically it was for helping countries that do not have a monitoring scheme to establish one. For butterfly monitoring, there are two ways to monitor butterflies that are included in this project. The first one is to monitor butterflies by counting them along a fixed route, and the other one is using another method, which is it's called a 15-minute count. And in this method, you can count butterflies for 15 minutes, and there is an application that will register your route. And data are collected mainly by volunteers. And there is an application ready that we can use. It's multilingual. And you can either use the butterfly count, or you can use, or you can do a transect. Here is a map that with the blue dots are the transects. So you can see that in the UK, in the Netherlands, in Belgium, and Spain and France, there are a lot of transects, and also within the ABLE project, we had Cyprus is also participating with a transect, and we are here with the green dot, and also other countries are participating and started a butterfly monitoring scheme, like Portugal and Italy. So with the help of the ABLE project, we have started a collaboration with the Greek Cypriot community and the Turkish Cypriot community, so to create a common monitoring scheme. So we have one coordinator for each community. And we had last year we had a workshop that was organized here on the island. We have 24 people coming that were interested in butterflies, and also to participate as volunteers. And we set up the Cyprus Butterfly Monitoring Scheme. Also, we have created a field guide to help volunteers to identify the species that can be found in the island, the most common ones. And also they have provided us with nets for volunteers. Here with light green, you can see the countries that are new established butterfly monitoring schemes through the ABLE project. So Cyprus is one of them. Until now, we only have one transect and several 15-minute counts. We are in a very early stage at the moment. Also through the project, we have participated in meetings and workshops, technical ones, and also as coordinators. I will agree with something that Martin said earlier, that volunteers are not it's not a free ticket, so we need to find funding in order to sustainable monitoring, to secure the monitoring actually. And because they are expenses and the tools are there, we have the tools, we have the applications, but we need to find the volunteers. So we need more volunteers, and if we have the data, we can use them to feed EU and national policies, because Cyprus at the moment is not participating in as a country in several indicators like the grassland butterfly indicator, or the woodland butterfly indicator, or the climate change indicator. So there are a lot of indicators right now, but we cannot participate because we don't have the data. We need systematically data for at least 2 years to be able to participate in reports like the grassland butterfly indicator. And citizens, the volunteers, are the key for us to help us study and systematically monitor butterflies. I was very short. Thank you, and I don't know if we have time for questions. Savas?
Yes, Ellie, thank you very much for this very brief, indeed, presentation in order to assist us keep on with the time. Very, very nice, the information you presented. I think that, yeah, we can have a couple of questions either directed to you, Ellie, or directed towards Mr. Galanos, that was our previous speaker.
Yes, I see a question. Yeah. We were supposed to have another workshop this year, but due to COVID, we postponed it. But I hope that the situation will allow us to have a workshop here in Cyprus again in May. But if we are not able to do so, we are thinking about doing it online. So have a workshop online for identification of butterflies. And also for volunteers. We have the guide now printed, so whoever is interested can contact me, and I can provide the field guide, or they can download it on the EBMS website. So yeah. I will, and also if anyone is interested, they can. We have a Facebook page, Cyprus Butterfly Study Group. They can become friends. They can join, and there we will announce any news about the monitoring.
Thank you, Ellie. Do you have any question? If someone wants to speak, raise their hands. Yes, Ellie, please.
Martin wrote a comment.
It was a comment on joining applications.
We should, Martin, yes. It would be nice to have something specifically for the island. It would be very interesting.
Okay, so waiting for other questions. Ellie, I would like to ask something. And since already Martin said a comment there, previously in his presentation, Martin Heliker presented some difficulties they are facing in their effort as BirdLife Cyprus to attract volunteers and train them. And I'm definitely sure that monitoring birds is totally different than monitoring and identifying butterflies. What I would like to ask was, on your perspective, what do you think are the main challenges that you're facing in acquiring the proper volunteers that could assist in this not opportunistic but more systematic monitoring of butterflies?
Well, I think that if we can acquire funding and we have trainings, then I think it won't be a problem, because we don't have many species. and they are not very difficult to identify, to tell you the truth. So if we have funding and we organize trainings, and also if it doesn't matter where you do the monitoring, it can be a walk near your house, it can be in a park that you go every once a week or twice a week, or it can even be you can do a 15-minute count if you go for a walk in the forest or in the mountains or whatever. 15 minutes are not a lot, you can do it. It just you need to have the you have to have, you know, like train people. And also in if we're going to do an application for specifically for Cyprus, you can also have like you can also take pictures, and or you can have as your, you can, if you know if you enter your position to the application, a list can come up and with the species that you can observe in the specific area, so you will have an idea of what you see. I think there are ways to do that. We just need funding. And also the other thing is that in general, data that we have are more, it's very patchy in time and in space, and it's biased towards countries that have funds for doing monitoring. I mean, I was in the latest online workshop we had for Able project in Spain. They said that the government gives money every year for butterfly monitoring. I mean, it's in their budget to, you know, to have money for this. But here in Cyprus, it's not in our culture. It's not in our I don't know. It's not high. It's not a high priority, or other matters more.
Yeah, I totally understand what you're saying. So I have seen that we have the hand of Martin up there. I want to say something, and we have a comment from Dr. Martino Kelly.
Yes, Martin.
Yes, thank you, Ellie, for a very interesting presentation. I think a lot of the challenges are very similar, aren't they, in trying to establish these citizen science things. I mean, I meant what I said in the chat. I think we should look at this more globally and think about trying to set up teams that could do butterflies, birds, plants, other things, you know, look at it from the angle of engaging people and biodiversity as a whole.
Yes.
And I think there's a lot of room for that. I also think that the situation with COVID has led a lot of people to do, especially during the sort of stricter lockdown times, more walking than they used to, be out in the countryside more. So I think the timing is good. I think there is more interest than there was certainly 15 years ago when I started with BirdLife Cyprus in this, so there's an opportunity. And I mean, the last thing I wanted to say is that, to be fair, to acknowledge that the Department of Agriculture does give us some funding for the common birds monitoring, because Cyprus has to report on the state of common and farmland birds to the EU, so they do support us on that. But we know, and I'm sure Ellie knows very well, that the butterflies are also seen as a really good indicator of the state of the countryside. You mentioned it, in fact, Ellie, and especially with farmlands as well. So, you know, that's something that we can put into that equation when we're looking at how we can expand these schemes, and also, you know, as we're all agreeing, how we can find money to run these schemes. So we could go together to the Agriculture Department to look at possibilities there.
Okay, yeah, that would be great.
Okay, thank you, Martin, for your intervention and the comments. I would say to proceed with answering the last question, the one from Kelly Martino, and then we can go for a brief break and continue with our schedule.
Okay. Okay, Kelly Martino is asking if we see any changes in species trends with the opportunistic data we have. We have not analyzed this data yet, but we have almost 9 years of data. So this is, we are planning to do so. So yeah, with able, I think we should not focus only in areas that we should focus through the island, and also in not across the island, not only in specific areas. It depends, because we will depend on volunteers. Whatever, and they are very important. Whatever they are, whatever suits them better. We just need people going out and counting butterflies. So thank you.
Thanks a lot. Thanks a lot, Ellie. As already Giannis wrote down, it's obvious that there is room for a lot of discussion in the matter of monitoring the fauna in Cyprus. I'll remind everyone that we'll have a lot of time later on when the sessions come to an end to discuss among ourselves all the rest of your questions, all the whatever you need, and the ideas for common collaborations and projects. Saying that, we'll proceed with a 10-minute break and come back to you with the second sessions of the day. Thank you all.
Who? Good evening, everyone. I think it is now time to move to our next session, which is about road ecology. There will be talks about roadkill monitoring and solutions to reduce the effect. I am Βασίλης Λίτσκας. I am a researcher in Open University of Cyprus, and I work in the project EnVeROS. So we are starting with our keynote lecture from Mrs. Wendy Collison-Jonker. Wendy works for the Endangered Wildlife Trust, a South African NGO, where she manages the Wildlife and Transport Program. She is the author of several road and rail guidelines, book chapters on road ecology, as well as international peer review articles. Her work varies across Southern and East Africa, primarily for road and rail ecology. Unfortunately, she had serious connection problems during these days of the webinar. So we have her presentation recorded, and I will try to upload it for you in the platform. And please let me know if it is okay and if you can hear the presentation.
Βασίλη, νομίζω δεν ακούγεται.
There is no sound.
Okay.
I think there is, but you need to rise it up.
Sorry for this, I will try once more.
Good afternoon, ladies and gentlemen, and thank you very much for the opportunity of allowing me to give this keynote address introducing the field of road ecology. Firstly, I'd like to start with an overview of linear infrastructure and ecology, and then hone down to technical advances for partnering with business and data collection 101. So firstly, I think most of us are aware that linear infrastructure and the transportation is critical for human economic development. We need roads, we need railways, we need fencing to often bisect some of the areas that we are developing. Power lines, pipelines, as well as waterways, all improve human livelihood. And these global transportation networks are developing at a huge rate globally, particularly in many of the developing countries such as Africa, Southeast Asia, and also South America. Now, I know I'm speaking to the converted here, as we've had many wonderful presentations regarding the indirect and direct impacts of linear infrastructure. So primarily the impacts on biodiversity from road ecology, one of which is pollution, whereby this can be caused by vehicle emissions, noise, or light pollution. We also know that roads can bisect populations, causing genetic biodiversity, and often roads provide access to previously unobtainable areas and often encourage the harvesting of illegal logging as well as poaching. The more direct impacts are collisions, and here we have some of the examples of the linear infrastructures that I showed you earlier. We have roads, rail, power lines, aircraft, fencing, and marine and coastal shipping. Now, what I find very, very interesting is that the impacts of roads, primarily roadkill, was known about since the 1920s. That's almost 100 years ago when the problem was first recognised. And this quote by Stoner in 1925 speaks, "As a killer of men, the automobile is more deadly than typhoid fever and runs a close second to influenza. Not only is the mortality among human beings high, but the death-dealing qualities of the motor car are making serious inroads on our native mammals, birds, and other forms of animal life." That's interesting that it was known about, as I say, almost 100 years ago. So in order to quantify this problem, scientists established a goal in the 1980s for road ecology, which outlined the statement to provide planners with scientific advice on how to minimise or mitigate the negative environmental impacts of transportation. But how do we go about doing this? So firstly, I feel that we need to broaden this. It's not just road ecology, it's linear infrastructure ecology. So it should be a goal for linear infrastructure. And then what do we mean by scientific advice? I would say this is about needing data to quantify the problem so that we can then guide appropriate mitigation. And of course, the standardized approach to gathering data will therefore allow different data sets to be comparable. And when I say a standardized approach, this refers to the methodology. And there are clearly different needs as to why we need to quantify the data and why we need to gather it, depending on what sector you represent. So, for example, many linear infrastructure agencies have environmental sustainability as one of their goals. And as part of this goal, there is an obligation for human safety, and when it comes to power lines, uninterrupted service. Often insurance companies can reduce their high premiums through a reduction in many of these collisions, which would then be a win-win not only for biodiversity, but also human well-being. And then, of course, the reason for quantifying the problem may also be valuable for the road engineer, particularly when it comes to the location of collision hotspots and where they may apply mitigation, such as road crossing structures or use of the underpasses. And then for myself as a biologist, I'm interested in animal behaviour, the population and the genetic impacts. So how do animals behave around railways? What impact is that having on the population if they are unable to traverse a railway or a road network? But ultimately, the goal for gathering mortality data is the same for all of these different entities: to prevent, reduce animal collision mortality. But one of the challenges is identifying where to start. And this is particularly the case in many of the developing countries, whereby there's a problem and it's about how do they go about solving it. And it also means that there are priorities that will differ, as I mentioned in the previous slide, depending on who you are. So again, for example, if you are an energy provider or representing someone from the road and rail sector, you will most benefit from the collisions being prevented. And this is regardless of the species involved or the adjacent habitat surrounding the linear infrastructure. A biologist may only be concerned with threatened species, whilst members of the public would certainly cause a massive outcry. Joe Public does not want to see dead animals on the roads. And of course, much of the above will be dictated by a funding agency, and therefore the levels, the challenges and the limitations of how much data want or need to be gathered. So how do you prioritise and build up a picture of the true story of what is going on? So this is when I come to how we gather baseline animal mortality data for road ecology. So I've split this into two sections. There's the researcher and the expert, and then there's the citizen scientist. So the benefit of asking or funding a researcher or an expert to undertake gathering the baseline data is that spatial and temporal carcass surveys will be undertaken, and usually in a robust and scientific manner. Now, this is useful if there are threatened species or habitats which have already been identified. It can also assist with the location of collision hotspots that will later then guide mitigation, although it does require fairly long-term data gathering. It's not an overnight data collection, and consequently the survey effort can be expensive and it can be time-consuming. However, on the flip side of the coin, the citizen science or the volunteer or Joe Public usually rely on gathering your ad hoc data, which consequently leads to the data being questionable, and it's not always 100% reliable identification-wise. Very often in this case, the sampling effort as opposed to a researcher can't be measured, and it often focuses on charismatic species. For example, in the South African database, whereby we have been gathering mortality data, we have a large number of mammals and very few for amphibians. But one of the advantages of asking members of the public to participate in surveys is that it does create an opportunity for the start of more intensive surveys to be undertaken by an expert. And ultimately, we'll be able to start with having an idea of what priority areas there are and ultimately guiding future decisions. So the Endangered Wildlife Trust's Wildlife and Transport Programme, which is the programme that I manage, is a South African NGO. And we have been working in the road and rail ecology sector for the last 10 years. We have, as I've already outlined, we have two types of data collection. One of the ways in which we gather expert data, in addition to deploying scientists and researchers out in the field, is working with our road agencies. Many of our road agencies have teams who drive these routes regularly, helping drivers who are in difficulty. And consequently, we have trained these teams in identifying species that have been killed on the roads, recording this data, and then this data is all submitted to a centralised database where we can monitor what is happening on particular highway in the country. We apply the same method to railways, so rangers who are residing close to railways are trained in gathering the road and rail mortality data. And we also do the same for power lines, where we undertake surveys of electrocution and collision data, and this all builds the bigger picture as to what is going on. We also provide training materials. Now, currently we have manuals that are issued to all of the teams where there is training within the manual about how to identify species, and then photographs as well as where you may find them. And of course, there are various reporting examples that you could use. For example, the Survey 123, tablets, various cell phone apps, or you could simply use an Excel sheet, which is basically your raw data sheet. Currently, we're in the process of switching from manual entering onto a piece of paper to tablet form. This is how we gather our data. So we issue all the patrols with whiteboards, and when they find a carcass, they write on the whiteboard the species. They also write the location, the date, and the member of staff that found the carcass. And then, of course, for human safety, they then remove the carcass from the road and place it on the adjacent habitat at least 50 metres away from the road. This is entered into our centralised database, and this is kind of what our database looks like. So we have all the GPS coordinates, the date, the species, and the member of staff's name. If possible, we also record fence type and adjacent habitat. We also offer additional support. So very often, as these teams work 24 hours a day, sometimes it's not always possible for them to identify the species. And so we have created a WhatsApp group where they can contact us directly and query some of the species that they are unable to identify. And of course, it's very, very important to provide feedback. And we do this in the way annually of providing them with a certificate and a prize for the member of staff who has managed to do the best number of identifications. We haven't based this on reporting because clearly some sections have more roadkill than others. So currently we work with 3 road agencies in South Africa, and we have started our partnerships with them at different times. This goes back to 2011, which started with the N3TC, and as the years went by, we gradually started a partnership with Bequena and then Track N4. And here you can see that over the years, due to the training methods that we have deployed, there has been an increase in roadkill reported. Now again, this could be also due to more traffic on the roads and resulting in more roadkill. It's really important that we also verify the data. So we encourage these members of staff to take photographs of the road mortality data. And again, we can see the effort here with the blue representing no photograph and the orange representing when there was a photograph. If we look at N3TC in the middle, for example, we can see that by 2018, there was almost 100% verification of the roadkill carcass for the mortality data. And from this, we can generate heat maps. This is one of our major highways that we work with, the N3TC, and this represents data from 2011 to 2018. And the darker red are our hotspot areas, and the yellow are the areas where there is less roadkill. So we can see there is a substantial amount closer to Johannesburg, which is our capital city. And as we start to head down to Ladysmith and Harrismith, the roadkill numbers decrease because these are rather rural areas. And then, of course, it's very important to have public awareness campaigns. And this is where we start to involve members of the public. So this is where we switch from our expert surveys to raising awareness with the members of the public to encourage them to submit ad hoc data. The publicity materials that we use here are posters, flyers, and we've even developed a cell phone app which allows members of the public to report whenever they find a roadkill, obviously only stopping when it's safe to do so. We're also very active on social media, where we have Facebook sites, LinkedIn, as well as Twitter. Here, people can post fairly ad hoc posts, something that's been in the media, and we also use this as a platform to post some of these scientific publications, which therefore encourages a whole spectrum of individuals to join these groups. Currently, our Facebook group has almost 2,000 members, and this is a huge reach globally. Interestingly, the data reporting methods in South Africa show that most people prefer to report via email. Our cell phone app comes in second, followed by a data sheet. And this, of course, may vary from country to country. And of course, reporting examples are often challenging. This is an example of an email that I received. And this is one of many emails that I receive on a daily basis. So I can get up to 100 of these each day, which I then have to sift through all of this information to find the information that I need in order to enter this to the database. So whilst I've been talking, I would imagine many of you have been scanning this, and therefore I'll ask the question, how many roadkill have been reported in this rather long email? There's one. And of course, I then have to respond to this individual because, as I've said, feedback is incredibly important. And the feedback should not be just a thank you. This member of the public has gone to a huge amount of effort to engage with me, not just about the road mortality data, but something that has been happening on his property. So of course, I then have to respond in the appropriate manner. This can obviously be very time consuming, but it is beneficial and does pay dividends to building up your database. As I said, we're very active on social media, and this is an example of one of the reports that I found on social media regarding a road mortality in one of our protected areas. And of course, this is where we question, a protected area is a sworn custodian of biodiversity. So why is road mortality happening there? I have recently published a paper on this, so many of you are welcome to go and look this up. And it's called Protecting the Protected, which may be of use for those of you who do work with mortality data in protected areas. From these data that we have collected from the members of the public, this enables us to then plot all of the road mortality data points. And we'll see from the map on the left that there are some very, very dark areas of where the mortalities are occurring. And then there are other areas where there is less coverage. Now, this is where we need to note carefully that this is reported sightings. It may not reflect the actual sightings, so therefore we need to interpret these maps with caution because some of the roads may be less driven than others. However, the map on the right can be used as a heat map, and therefore, as I stated earlier, we can send a scientist in or researcher to undertake more robust surveys to see what's really happening with the species and the habitat involved. The type of report that we get from members of the public, as well as our experts, show that mammals are far more the most reported, followed by birds, and then there's a fairly large chunk of unknown, where they can't even identify it to a taxonomic group level. Reptiles are still fairly underrepresented, and amphibians are only 1%. From members of the public, as opposed to the expert surveys, only 45% of the photos had a photograph, which means that we could not verify everything that was submitted. And as I said earlier, the feedback is really important. So not just to an email, but if something is submitted on Facebook, it should be provided with comments and also a report, so members of the public can see how their data is being used, and also to give them a big thumbs up and thank you. One of the other things that we do is to set challenges to many of our donors and corporates who support our work. Here we see a graph on the left where members of one organisation have been gathering mortality data for us, and we've set it as a competition, and at the end they are awarded with a certificate. Now, when it comes to designing your data sheet, there are a number of things you need to consider. I believe that what's important is what you want to know rather than the need to know. So what I mean by this is that you can go on and collect lots and lots and lots of data only to find that some of it is unnecessary and therefore time consuming for the data collector. In saying this, I also believe that more is better. So we're in a catch-22 here. When I say more is better, sometimes a few years down the line, you realise that there is something that you need to know, but if it hasn't been collected, then you'll never find out. And then consider how you'll be receiving the data and transferring it to the master database. As you saw earlier, we provide many, many platforms. This is to ensure that as many people take part as possible. But again, it can be very time consuming. And then, of course, who owns this data? If you are working in collaboration with the university, there is possibly a need for a joint collaborative agreement, and certainly the same with many of the road agencies. And this is particularly the case if you intend to publish the data. And I do have additional materials for data sheet design available on request. So now what? What do you want to do with your data once it's been collected? How long do you collect it for? When is enough enough? And what I mean by this, as you saw with one of our slides earlier, the N3TC, we've been gathering road mortality data since 2011. So we can't endlessly go on collecting and collecting data. At some point you need to make a decision about when, where and how you mitigate that data, and of course how it has been interpreted. Of course there's no silver bullet, and there's often pressure from the relevant agencies to deliver results as soon as possible. This is where some very expensive mistakes have been made globally, whereby relevant agencies have applied pressure to the researcher and they've gone ahead with mitigation measures after 1 year's worth of data. Unfortunately, many of these studies haven't been published because they failed, and as scientists we know that failure is often rarely published. So using the data, it's important that once you've collected it, you have a clear idea of how you're going to utilise it. So firstly, you need to identify the areas of possible concern. And if it's citizen science, then this will be based on the reports, leading to more robust surveys using a researcher, your expert. Identify the critical sites that may be of greater concern than others. So my hotspot showed that there were many areas across the country that were flagging as areas of concern. But if you have quite a strict budget, then some will have greater priority than others. And these may be areas that are adjacent to your protected areas that require more monitoring. Again, identify the most common species, but be careful here. Very often the common species are often the ones that are reported most often because they're charismatic. As we saw earlier, many of the amphibians aren't reported, and these could be threatened or endangered, and it simply goes under the radar. And sourcing traffic data and also crash statistic data will be valuable in much of your interpretation. So your data is not just about the what, it's about the species involved in the collision as well as the why. Knowing the why it happens will guide mitigation. I'm also a strong believer in networking and working with partners. So this is where social media comes into its own, where you can promote the work that you are using with your various donors. I also do a number of newsletters and regularly campaign. Certainly with the holiday season coming upon us now, this is an ideal opportunity to do your campaigns. We also undertake a number of awareness days, and this can be with members of the public, adults, also school learners. So I feel it's important to build a database of all of your contacts. Don't limit this broad database. Make sure it includes everybody from all disciplines. And through sending out your newsletters, you can use things like MailMerge or MailChimp. These are good messaging tools that sends out individual emails. And consequently, through your networking, this can lead to enhanced data collection, new partnerships, projects, and ultimately funding. And there are many other data collection methods, one of which has just been published by Schilling et al. And it gives an overview of many of the observation systems that involve volunteers. So here are my take-home messages. There's no silver bullet. Vary your tools and adopt a number of approaches to encompass all members of the public as well as your experts. If you are providing training, try and do it face-to-face or through flyers and online materials. Encourage where possible a submission of a photo that can be verified, and try and incorporate the sampling effort on regular survey routes to record non-roadkill. Particularly if you want to publish this data, this is very, very useful. And as I've learned, you need a designated data enterer or consultation of a statistician who will help you to interpret that data. And it's important to provide feedback, which can be through your reports, newsletters, social media. So thank you for the opportunity of allowing me to give this presentation. I will try and take questions at the end, but I would like to take this opportunity to wish you all a happy and restful holiday break and stay safe on the roads.
This was the presentation by Wendy. I hope you were able to follow. It was a very inspiring presentation, and we will have the opportunity to discuss it at the end. We will now move to our next presenter, Dr. Annette Mertens. She is a freelance wildlife biologist. She is very active in planning, proposal writing, and coordination of nature conservation projects with specific expertise on life projects. She is the project manager of the two life projects, the Life Strate and Life Safe Crossing. And Dr. Mertens, the floor is yours, and I will try to upload your presentation.
Hello. Hello, do you hear me?
Yes, we can hear you.
Okay.
Ioannis, if you can help me with the presentation, because I see that the system is not is taking some time to load. Is the presentation number 6?
I'm doing it.
Thank you very much.
Okay.
Annette, you can start.
Okay. Hello to everybody. Yes, I was invited by the organizers, whom, by the way, I want to thank a lot for giving us the opportunity for this presentation during this final workshop, and compliments for this very interesting project that you have managed to carry out. So I was invited to give a presentation about the LifeStrade and Life-Safe Crossing projects. LifeStrade is these are 2 LIFE projects funded by the LIFE Fund of the European Union, which probably most of you know. And LifeStrade is finished, and Life-Safe Crossing is, like, let's say, a second phase, which is ongoing. Okay, so as I told you, LifeStrade was the first project. It took part only in Italy, and it lasted until 2016, and was then followed after one and a half years by the Life-Safe Crossing project, which is developed in 4 European countries: Italy, Spain, Greece, and Romania. And it specifically targets 3 large carnivore endangered species: brown bears, Iberian lynx, and wolves. So starting from the LifeStrade project, the main objective of that project, which is also one of the core activities of the new project, was the development and testing of an innovative tool for the prevention of roadkills, which acts simultaneously on wildlife and drivers. I am going to tell you how it works. And besides this project also intended to work a little bit more on the policy level for the development of management and monitoring protocols together with the regional governments, and of course activities for the dissemination and awareness raising regarding the impact of roads on biodiversity. So as I said, this project was carried out in central Italy, in Umbria, Marche, and Toscana region. And it started basically with an assessment of the road mortality in these areas, because back by then and still now, Italy doesn't have a really very comprehensive database about roadkills, and this one was one of the most largest initiatives to assess the amount of roadkills on roads. Actually, we did the comprehensive monitoring for 4 years on 250 kilometers, and so this was also mapped, and we identified hotspot areas, and so this gave us a picture of the situation of road mortality in the project in the 3 regions, and of course helped us also to identify the sites where we went to work. So as I told you, let's say the core part of this project, which is part also of the New Life project, is this ABC, so Animal Vehicle Collision Prevention System, which is working as follows. This should be an animation, but since this now is a PDF, unfortunately there is no animation. But anyhow, in the upper right you see a kind of a small device, which is an infrared detector, which detects the presence of animals on the roadsides, which is indicated with number 1. The signal of this, when this relates the presence of an animal, goes to a central control panel, which sends a signal to an alert panel for drivers, which is inviting the drivers to slow down. On this alert panel, there is a radar Doppler device, which measures the speed of the upcoming car. So it measures if the car is driving too fast or, let's say, slow enough. If the car decreases to a certain speed, the system stops acting. Whereas if the car continues at a too high speed, let's say a signal goes back to the central control unit and activates a scaring device for wildlife, which chases the animals away. Like this, we have a system in which the animals are alerted only if there is a car in the nearby, and the cars are alerted only if there are animals in the nearby. And like this, we avoid that there is a real barrier for animals. We avoid that cars are constantly alerted, and so we reduce the level of habituation both for animals and the drivers. This system is also accompanied by a modem, which sends out at real time all the information about if the system is active or not, and about everything which is happening. So all the different components of the systems which are activated, which is of course very important for us to monitor the function of the system. We have tested, so first of all, developed this system and then tested it in 17 sites in central Italy. We have then at a certain point also associated to it a thermal camera, which is instead of the infrared devices, which is registering the heat of, let's say, the warmth of animals or persons, and it gives a very, very accurate image. It goes to detects animals up until more or less 150 meters and provides a very, very detailed information also, for instance, about the size of the animals, the direction in which they move, and like this, of course, we can much better understand what it is happening in the moment in which this system is activated. This is a little video which Vasilis told me he will show at the end, because this we don't have an animation here. So after the end of the project, after 3 years of, let's say, installation of these devices, we have had almost 2,400 days in which these systems have been active. Of these days, in 7,500 cases almost, there has been a triggering of the sensors, which means that the system has relevated the presence of an animal on the roadside. In 4,635 cases, there has been the triggering also of the scaring device for the animals, which means that there was an animal on the roadside, but in the same moment there was also the presence of a car which was driving too fast, which would be that there were 4,600 risk situations in these 3 years. But in these 3 years, we registered the presence, let's say the killing of only 7 animals in the areas where these devices were installed. And by the way, in 6 of these cases, either the devices were not properly working or they were still being implemented from the technical point of view. As I told you, this was a testing, a first development and testing period. So we can say that the effectiveness of these devices was almost 100%. So as I told you, this system has for sure the advantages that it does not alert cars and animals and drivers every time when they are in the area of such a system, but only in risk situations, and like this we reduce the habituation. They are very good systems for hotspot areas because they cannot cover very, very long distances. So, of course, you cannot cover kilometers and kilometers, but they are very good when you know where the most risky areas are. When the project was finished, this let's say there has been a lot of interest also from other parks and provinces in Italy and regions in Italy who wanted to adopt this system. And so actually we have, let's say, the company who has developed has installed such system in many other areas. And since we saw that there was this interest, we developed a second phase project, which is the Life Safe Crossing project, which started in 2018 and is still ongoing. As I told you, it is taking place in Romania, Greece, Italy, and Spain. In Romania, Greece, and Italy, it is targeting bears. In Spain, it is targeting the Iberian lynx, because there the Iberian lynx population is recovering. It is doing better than it used to be, but it is suffering very much from roadkills. And all these species are not only suffering from the direct mortality on roads, but also from the fragmentation represented by roads. So the objective of this new project is also, of course, again, the monitoring of the impact of roads in all the project areas, because this gives us also the guidance of all the implemented activities. And we are going to install these ABC prevention devices, which I showed you earlier. But we are also we are working also on reduction of the fragmentation of the habitats in order to favor the movements of the large carnivores. And finally, we are giving a big importance, of course, to the raising awareness, specifically of the drivers, in order to gain their awareness about the importance to drive carefully. So the project started with, as I told you, with monitoring activities. We have used the data of all the project partners about wildlife, so the historical data about wildlife mortality, and telemetry data about bears, in order to identify the main hotspots of wildlife mortality and the hotspots of where the animals cross the roads. All this data was then processed by Michal Bill, who is going to speak later, with his KDE plus method. And like this, we produced maps of identifying the risk hotspots where we are, and we need these maps, of course, to plan the concrete interventions. We also monitored and did a characterization of a lot of crossing structures in the areas where the roads represent a barrier effect for the target species. Carmen Rosell, who is going to speak after me, is a partner of the project, and she has provided guidance about how to characterize and describe the underpasses, and how underpasses should be adapted in order to favor the passage of the animals. And we did this characterization already on 360 underpasses, gaining a lot of course, important information. In Greece, and this is also going to be presented in a later presentation, we have developed an innovative tool for the monitoring of the passage of the animals, and we found really interesting data about what is all the traffic of the wildlife under the underpasses. But as I told you, this is going to be told later by Yorgos Liberopoulos. So we started now with the installation of these 27 ABC prevention systems, the ones which I told you earlier, which were installed during the LifeStrade project. We are going to install them in all 4 project countries. We have started doing first surveys in the Abruzzo region in central Italy, and for the rest we are doing, let's say, the initial administrative burdens in order to purchase the systems, to get all the permits, etc. In the same areas, we will, and we have already started doing it, install a so-called virtual fence. Maybe some of you know what this is. This is a system developed by an Austrian company. It is similar to the Svareflex reflectors, but they are not passive reflectors, so they don't reflect the headlights of the cars, but they are electronic devices which are put on the roadsides, and the electronic device is turned on is activated by the headlights of the cars, and then emits noises and different lights which can be selected. They can also be linked to each other by Wi-Fi, so that only when the first device is activated by the headlights of the car, it transmits the signal to the other devices so that they all turn on together, and so this increases the effectiveness of this tool. As I told you, we started doing activities to improve the permeability of the roads for wildlife. We have started especially by cleaning underpasses, taking out garbage and mud and doing some cleaning, and the next steps will be to really further implement the passage of the animals by mounting fences and vegetation, which should lead the animals to encourage them to pass under specific underpasses instead of passing over the roads. Then one thing which is quite particular to this project is developed due to the insight that during the Livestrade project we made some questionnaires with drivers especially, and we realized that most drivers, when asked what should be done in order to reduce the risk of killing wildlife on roads, were saying that the roadsides should be changed or that wildlife should be removed or things like this, but only a very, very small percentage of the drivers were actually aware of the fact that driving slow and being careful is the key element, is of course of key importance. So our intention is to make a very, very strong awareness campaign for drivers in order to first of all raise their awareness on the importance of the danger to incur in a roadkill, but also that they keep this danger always in mind when they drive, because you might know that there is such a danger but then forget about it while you're driving. So what we did is that we contracted a company, a neuromarketing research company, which is an innovative neuromarketing tool. They developed a set of panels, road panels, the design of road panels with which we wanted to attract the attention of people. And they then selected 30 test persons. And in a testing setting, they had this driving simulator, and all these persons were submitted to an electroencephalogram, and they had special glasses which identified the movements of the eyes. And like this, we managed to see how the sight, how the view of the eyes reacted to different places of the panels, to different features, to the colors, etc., and also how the brain reacted to different signals. And this told us, first of all, of course, how strongly the person reacted, so if the panel had a strong effect or not, and also how to improve the effectiveness of the panel. So if maybe a writing was not in the same position, in the right position, or if the colors should be changed, or if specific items were not visible enough, etc. And like this, we developed a set of panels, which we hope will be particularly effective since we did this testing, and we have started installing them on the roads in Abruzzo and also in Terni province in Umbria region, so in Italy, and they will soon be installed also in the other 3 project countries. We will, as soon as they will all be installed, we will also start the monitoring of them, of their effectiveness, by seeing how the drivers react when they see these panels, in order to see if they really have an effectiveness. Of course, we hope so, because we have worked a lot on it. Well, to close, of course, awareness-raising actions are not limited only to the drivers on the road, but to the general public, because also, of course, also future drivers are important, and the general public. So we are developing, let's say, the general awareness activities like production of gadgets and leaflets and posters, and distributing them. And in order to raise the attention and to involve younger people, we have developed a video game. It's called Avoid It, and it is available both on on the stores for mobile phones. in which the user should try to avoid killing animals, and let's say is awarded if it does manage, if he or she manages not to kill animals. And with this, we want to reach young people who will be the future drivers, in order to at least pay attention to the fact that there is a problem of animals crossing roads. And finally, as you also did in your EnVeROS project, we developed an app with which we would like to encourage the general public to signal to us when there is when they see a dead animal, or they incur in an animal vehicle collision. And this, of course, is mainly also done for awareness raising activities. It would be interesting to maybe communicate a bit also with you guys of the EnVeROS project or others, to see how, let's say, the use of these apps could be enhanced mostly, and maybe also to coordinate a little bit the results, so that that we don't do things in parallel. The last thing I want to tell you is that, as you probably all of you know, is that in January 21, from the 12th to 14th, there is the International IEN conference, and our project, we have a technical specific workshop about our project on the 12th January in the afternoon. Of course, we would like to all invite you. We will go a little bit further into detail on the project, and we will then do some discussion rounds in order to gather also the inputs from other people, from outside, to see what you think about what you're doing, and maybe provide also some positive or negative feedback, which helps us going on the project. And last but not least, I hope to see you at the final conference, which we will organize in 2023. Hopefully by then we will be free to travel again, and hopefully we will see many of you by then. Thank you very much for the attention.
Thank you very much, Dr. Mertens, for your very informative presentation. And while I will try to share my screen and show you a few seconds video, we have time for a couple of questions, so you can text them or raise your hand.
Yes, this video, which Vasilis is showing you, it's a very short video. It is the reaction of an animal when this roadkill prevention system goes on. You will see an animal, you will hear from far a noise of a coming car, and then a noise and the reaction of the animal. Okay, it's finished here. You can stop it now. Thank you.
Thank you very much, Annette. Yes, Savas?
Yes, thank you, Vasilis. I need to congratulate the presenter for the presentation. I mean, it was really interesting. A lot of work in both projects that Dr. Mertens showed to us. I had a number of questions. They're kind of short questions regarding the animal vehicle collision prevention system that you showed us. That indeed, from my point of view, it's very interesting, impressive the way it reacts with the animal and the drivers. In Cyprus, we have different animals that the ones that your project is aiming. We have smaller animals, and one of my questions was, what is the ability of this system to spot smaller size animals like either reptiles or birds that are flying lower near the the roads. And perhaps if you have any cases of vandalism, people destroying the system, yeah, another issue, sorry for taking too long, it's the issue of personal data. You showed that you have some cameras showing the roads. Did you have problems with the authorities giving you access to allow you to put cameras showing the road and recording information of the roads? Yes, thank you.
Okay, thank you for these 3 questions. So the first one was about the size of the animals. When we developed initially this device, we decided to concentrate on mammals and starting from, let's say, around 5 kilos up. But then we installed also these remote cameras with these infrared cameras, which I showed you, and they are detecting also very, very small animals. We have seen on images that they are detecting animals of a size of a bird, for instance. Of course, there is rather a matter of the behavior of animals, because in case of reptiles or amphibians, they are much smaller and they will probably not react to the scaring systems, whereas birds are just flying around more randomly. So probably these are animals which are not the most suitable for such a system. I would say this system is most suitable for medium and large-sized mammals. Although, as I said, this thermal camera can detect also very, very small animals. The second question was about the privacy.
The vandalism.
The vandalism, yes. We have, interestingly, during the 3 years in Italy, had only 1 case of vandalism in which a system was destroyed, and 1 case in which a component was stolen. But I must say it was not really a big problem. What we initially feared is that people would be scared that this was a raider with which people, for making fines. And what we did is that on all the systems we put a small panel saying this is not a radar system, this is to monitor and prevent the road kills. And so like this gave let's say an explanation to people of what it is, and let's dispose them also a little bit in a better psychological situation in order not to vandalize the systems. So this was of course the Italian experience. I don't know how it would be in other countries, but we were also astonished that we had less problems than we thought, because also of course we were working with in the local communities at the beginning and at the extremities of the roads where the systems were installed, and so the local people knew that this was also something in favor of their territory. And the last question about the privacy of the images, we never had problems with that, because I mean there were usually no people on the road. We could not read the license plate of the cars. And from the point of view of the permits, we were working with the province administrations, which are responsible for the road management in the areas, and so they let's say provided themselves the authority, the permits to install the devices, but we have never had problems with this privacy issue, because we couldn't. I mean, this system does not allow you to identify the people who are driving through.
Thank you.
Thank you, Annette. There are 2 more questions. Ioannis, would you like to use your microphone? One from Giannis Voghiatzakis and one from Fabian. You can see them in the chat.
Yeah. How was the reaction of the public administrator on the newspaper? like bears and wolves, but what do you do when you okay, so I reply first to Ioannis. As I said, of course, hedgehogs and snakes are it's something different. We are this ABC prevention systems was specifically designed for bigger animals, and it's true that now we are working our, let's say, our target species, since this is a live project which is funded for specific the endangered species. We are targeting wolves, bear, and lynx. Which are for sure, let's say, charismatic, sexy species. But I mean, also what Wendy was telling us. I mean, when you show the things, I mean, when you transmit the message of the importance of the biodiversity or of the danger of the damage which you cause on the road in a right way, I think you can reach the people. This is, of course, a matter of how you do the communication. One thing we also try to do is, let's say, a communication channel we use is also trying somehow to tell people that a road or the presence of animals on the roads can be a danger not only for the animal but also for the person, and not only because of a collision, but because when you're driving in the dark and you see an animal on the road, you can get scared and lose the control of the car or something like this. And therefore, it's just the driving slowly and carefully is not only in the interest of the animals but also of people, of the driver themselves. And Fabian was asking, well, the reaction of the public administrations. Of course, I mean, in Italy, the province and province administration and the regional administrations are finally the ones who have the real burden when it comes to road kills, especially when people get injured or if there are damages on cars. And so these are bodies which are, of course, very encouraged to support projects like this, because they are the ones who then have to either compensate damages or listen to the people who complain. For regarding the national parks, which are our partners in the Life Safe Crossing project, of course, they have the interests of the protection of the biodiversity. And so the public administrations, also the road administration, which we have support involved and which is supporting us and have provided now, for instance, the permits to install these road information panels. They are very supportive of the project, because also they might be seen as responsible if there is an accident on the road. And so if there is an initiative which somehow prevents a problem, which is not only for biodiversity but also a danger for people, they are very happy.
Thank you very much, Dr. Mertens. We need to move.
Okay, thank you.
Our next presenter is Dr. Carmen Rossell. She is a biologist. She is a senior research consultant at Minuartia, a wildlife consultancy based in Barcelona. Her work focuses on human-wildlife interactions, and she has led numerous projects on ecology and transportation. She has co-authored handbooks such as the Handbook of Road Ecology and recently Maintenance of Ecological Assets. She is a university teacher, and she is also a member of the governance board in IENE.
Good afternoon. Let's try. I'm going. Okay, could you see my screen? I have to share my video if you want to see me also. Is it okay, Vasilis, now?
Yes, it's perfect.
So you see my screen, you can hear me.
Yeah.
Good afternoon, everybody. Thank you very much. I'm happy to be here sharing with you information this afternoon, and thank you to the organizers for inviting me. You will see my contribution today is particularly focused on showing you how useful the gathering of data is to define appropriate solutions to mitigate this conflict. Yeah. So yesterday already we saw, and today also with Wendy's presentation, we have get information about the effects of roads on nature, and I just want to remember this topic. Habitat fragmentation is not only dealing about barrier effect that roads and railways are creating in our landscapes, but also include all the different effects like habitat loss, disturbances, noise and light from traffic, invasive species going into the surrounding habitats, and of course the topic of today, which is the wildlife mortality, that when is involving large animals is also a problem of traffic accidents, of traffic safety. So let's see. So wildlife mortality in this miscellaneous, in this constellation of effects, the wildlife mortality is one of the most deleterious, the most negative one, because on the long term it's really threatening populations, and particularly affecting endangered species. So how can we reduce these effects? Oh, I all the time forgot. How can we reduce these effects is an important topic for all of us. And let me say you that not always is easy to predict where are we going to have the highest mortality. Here, for example, you have this in a study that we performed here in our region. We monitored these 3 roads. One a very small but crossing a wetland, a hot spot of biodiversity, low intensity of transit, another a medium intensity, and another with 30,000 vehicles per day, just in the same area. So if you see, this is the curve of atropellos, sorry, it's not translated. The animals killed doesn't correspond with the highest intensity of traffic road, but always we follow this. We found this pattern that is in the medium intensity roads are the most impacting one. So not always is obvious to understand which road is going to be more conflict and exactly where is the point or the stretch, the road section where we will find more important problems. Yeah. So monitoring, collecting data, particularly all this data that is provided with by volunteers, is important because they allow us with the appropriate software, the KDE Plus or the KDE Plus of Michael Bill will talk about it, is allowing us to see where we have more problems, but also which species, where are the animals being killed by traffic, but also which species. With, for example, here in a crossing of a river, we can have a high mortality of birds, while here the target species, the conflictive species are wild boars. So these data, target species and location of the roadkills, are essential, crucial to design effective mitigation measure. Yeah. Because when we are planning measures and implementing measures to reduce wildlife mortality, which is called defragmentation, because we are acting in, we are going to implement the measures on existing roads and railways. You will see now in the next slides that I'm going to show you different measures that you can apply for defragmenting, from reducing the impacts of roads, and particularly road killing, the number of animals that are road killing. See that it's not my goal to show you very in detail all the measures. We can talk about later if you have some question, but I would like to just see all the different type of measures that can be applied, and you will see the importance to have knowledge about where and which species are causing the conflicts. Yeah. So first, first mitigation measure is fauna passages, or also call it wildlife crossings. See that there is different types, 11 different types are defined in the Wildlife and Traffic Handbook. Some of them very small, like this amphibian tunnel that is specifically for this group, but also can be used for other small animals. This is very small, and this is the biggest one, the so-called landscape bridges or aqueducts, which are really providing a connection between the habitats of both sides of the roads. And don't think that landscape bridges are only for small animals, for big animals. These landscape bridges are very, very important also because they are habitats for butterflies, snakes, all kind of small animals can use it, and so it's providing connections for small animals also. Yeah? We have also specific wildlife under or overpasses. Here is another one, and modified over or underpasses. See, this one is not only for wildlife, it's combining the use of a small road, non-paved road, only used by the people and the neighbors, forestry areas, activities. But if we combine it with these strips of natural vegetation and screening to prevent disturbances from traffic, this can be used by wildlife also. Of course, all this must be combined with fencing. We will see it later on. Yeah, I would like to encourage you to think about modifying, adapting culverts, because culverts can be small, but in many places we have big drainages that with a low investment, with a low budget, it can be really used by animals. See here, you see this one that we have installed these platforms, these dry ledges, because this is all flooded, and it's been intensively used by not only by otters but also for many other species. Yeah, or this one that was corrugated steel with this material that wildlife, many species refuse to use, and just covering with natural substratum and planting vegetation, guiding the animals to this culvert, you can, let's say, convert this drainage in a fauna passage. And you will see that particularly when we monitor these big drainages, these big culverts, we found that they are also used by wild boars. I have not put the photos, but also brown bears, you will see later on, and also by bats that are using some species for crossing in a safe. It's providing a safe crossing for this wide number of species. And you can also, of course, when you have an important ecological corridor, like it was the case, here we have an ecological corridor, and we had these small drains of corrugated steel, and it was replaced by this small viaduct, which leave a safe passage for otters and all the other, not only terrestrial, but also for aquatic animals. Yeah. So before you have the otters dying in the road because they cannot, they didn't use these structures, and now we don't have any animal killed because they are using this viaduct. Yeah. So I told you before that fencing is often an obligatory part of the system. Wildlife crossing and fencing to avoid the animals going to the causeways, but also for guiding the animals. And this is a world. I'm not going to go deep on this. I will provide you literature if you are interested on more about fences, but just let me say you that you need to know which is the target, because the dimensions and the mesh size, it's variable depending on the species. You can always reinforce. For example, if a fence is not good, you can install this reinforcement. This is for specifically for wild boar. But the size of the mesh, the welded mesh, is different if you want to stop, I don't know, otters or wild boars. And for example, completely different if you go with amphibians, like many of you I know, I think you know, meshes cannot be used for amphibians because they try to climb and advance, and many of them can be trapped and be killed. So you need other type of fences, particularly designed for small fauna, and opaque, yeah, or even temporary, because as you probably know, amphibians are killed in a very particularly road sections, and particularly during the migration periods, particularly post prenuptial. So you can also use this temporary. So, what about small roads, perhaps in rural areas where fencing is not recommended at all? In these cases, again, we have a wide number of different measures. The management, the roadbed management is important. Is an important tool. Here, for example, cutting the vegetation makes it clear for when the vehicle is circulating, the animals can see it, and also the drivers can see the animals. So before here we had a big number of bushes which provide refuges for animals that were hidden here. So cutting the grass has been revealed like an effective measure, and we have been testing the effect here in our study areas. And it's particularly nice when you combine it with wildlife warning signs, but not the standards, which have a very low, or I must say, standard signs that are not effective. And even if this is very nice, awareness about lynx or birds, we have seen it's not so effective. But what is really interesting is this, which again needs data about where is the conflict point. Here you see these are reinforced because they have these bright colors and information about here, exactly here you have 800 meters that is a hotspot. And we close it, and here you see it's closed, let's say not active, you cannot see this panel, and this panel is opened only when the critical period comes. For example, if the conflict is wild boar is between September and January. So this sign is opened in September and closed in January. So not all the year when the people from the villages know, well, this sign is always there and I've never seen a wild boar, so it's a fake. So in this case, they know it's not a fake because it appears when really they saw the animals crossing, yeah? And when you combine this with cleaning road verges, let's say, clearing, this can be an effective measure. Of course, these innovative systems that already Annette has explained to you with very detail. So it's these cameras, sensors detecting the approach of the animals, and that can send messages to driver, these flashing lights. But also here is the life strategy group installing, and if you want to know what are they looking, they are looking the computer for the software that Annette has explained, yeah. So this is really a very innovative but also promising measure, as you have seen, even if, for example, here in our region, it's difficult to install because it's new and the road operators are not so willingness to install it. But for sure, it's an interesting measure to have in mind. And the electronic deterrence that also Annette has done the job to explain with very detail. So again, don't confuse, please, with reflectors. Reflectors, there are lots of papers now which tell us that they are not effective, the standard reflectors. These electronic devices can emit acoustic and light messages to animals. But the interesting thing is that you can change the combination. For example, the sounds and the colors of the lights can be changed periodically or when you want, just to reduce habituation, because this is something that in all species, not all, but many of them learn. The mammals, the ungulates, the large carnivore, when they learn, well, when this is, I hear the sound, but it's not dangerous, they are used to this stimulus and this is not working after some time. So when you are able to change the stimulus, then you can get a long-term effect, or this is what is being tested now in many different, well, there are different producers and different study areas, yeah. Last but not least, of course, this possibility to work with drivers, which Annette has also explained. But for example, here I'm showing the application of the monitoring system in Sweden, which allow you to report when you have a road accident, but also when you are driving and you are entering on one of these hotspots, the same map is alerting you, be aware you are crossing dangerous area, which is trying to cause, let's say, that the driver reduce the speed, circulate with paying more attention, yeah. Okay, so this is very fast travel trip for all the measures that exist or that are being applied. Here you have references, the European Land Traffic Handbook, an adaptation that is also translated to English that we produced in Spain, the Handbook of Road Ecology, which can be downloaded, at least these ones, not these. And I would like to recommend to keep in contact, to keep in touch with this website, Handbook Wildlife and Traffic, that is promoted by INI, the Infrastructure and Ecology Network Europe. And here you can find the first handbook, but it's from 15 years ago. And now we are updating, and in the next weeks, you will find a new chapter about maintenance that will be uploaded very soon. And you can also find a portal with dozens of different guidelines from different countries, and for example here about bats or pollinators, or well, I hope that you can find here some useful information for you. Yeah. So this is all from my part, to acknowledge your interest, to provide, you can download from our website some of these documents and others. And as Annette, I also want to invite you to join us at the INI International Conference that will take place very soon on January. And it's for sure the, let's say, the meeting point for all the people interested in road ecology, for sure in Europe, but also from other parts of the world. Okay, I think it's all I have to share with you by now. Thank you very much for your attention.
Thank you very much, Dr. Rossell, for your presentation on the solutions to reduce wildlife mortality. We have room for one question because the time is really pressing us. We have a comment. You can see the comments.
Yes, I go. By Yorgos, thank you. Okay, one short qualifying question. How would you characterize the structural functional similarities or differences between the three crossing structures, aqueducts or green bridges, and tunnels, and road runs underneath natural habitat? Thank you again. So, sorry, Yorgos, I don't know if I understand correctly your question. You are asking me about the differences between landscape bridges or aqueducts, and about wildlife passages, under or overpasses and underpasses, I understand. If it's this, if I understood correctly, well, a landscape bridge or an aqueduct, also call it an aqueduct, is a big structure that the Wildlife and Traffic Handbook define like more than 80 meters wide. But this is not the most important. The most important is that the vegetation is completely restored and covering all the width of the passage, which means that you have a lot of opportunities, different habitats, even for small habitats. Yeah, while the wildlife underpasses or the wildlife overpasses are smaller, usually 20 or less wide. And perhaps you cannot provide, for example, in underpasses, you cannot provide a continuity of vegetation cover. So you, it's more providing an opportunity for crossing, but do not ensuring the possibility of continuity of habitat. And this must be completely insured in a landscape bridge. I don't know if I answered your question, Yorgos, I hope so. Okay. Yes, perfect.
Okay, thank you.
Okay. Thank you, Vasiliis. Okay.
Thank you very much. We are moving to our next presenter, Dr. George Liberopoulos. He joined Cosmote, the leading mobile network operator in Greece, in 1999. He is heading the Research and Development Department, and he has been involved in more than 50 European and national research projects. He is also the author of over 60 scientific papers in the area of mobile telecommunications. Dr. Liberopoulos, the floor is yours.
Hello, everyone. Thank you very much, Vasilis, for the introduction. First of all, I would like to thank the organizers for the invitation. It's been a very interesting event, and I'm glad to participate in. Today, I will present an innovative wildlife monitoring and species classification solution developed from scratch by Cosmote's Research and Development Department in the context of the Life Safe Crossing EU project. The solution heavily contributes to the measures that are being taken for protecting the biodiversity in northern western Greece, and more specifically along the Egnatia Odos road infrastructure, so as to apply the appropriate interventions at the underpasses under study. To do this, we need to know not only which and how many species pass through its underpass, but also which underpasses a specific species, for example, bears, foxes, etc., prefer. The overall solution comprises an innovative end-to-end 24/7 wildlife monitoring system installed at 45 underpasses along the Egnatia Odos, an innovative wildlife detection tool for species categorization based on machine learning, artificial intelligence, and deep learning techniques, a cloud infrastructure for cameras, content, videos, and snapshots, etc., storage, processing, and the visualization through an intuitive web portal, and last but not least, a zero-touch statistics extraction and visualization tool. Let's go through the overall system architecture. Well, the solution is composed of two subsystems, the monitoring subsystem and the cloud subsystem, the cloud infrastructure. The monitoring subsystem is based on 3G, 4G wireless, battery-powered, ultra-low consumption cameras equipped with small but very efficient solar panels, guaranteeing very long operation. Each camera is equipped with an SD card for local storage of the videos and snapshots, and a SIM card, since it's wireless, which is required not only for the uploading of camera snapshots and videos to the cloud infrastructure upon movement detection, but also enables access to the camera's functionalities and the local content from anywhere, anytime. On the other side, the cloud infrastructure is composed of servers, virtual machines, routers, switches, etc. And it serves not only as a repository of the camera's content, but also is the place where the processing of the camera's content and the extraction of the statistics are performed. Finally, the cloud infrastructure hosts a web portal for visualization purposes. The only prerequisite I would say is that there must be wireless coverage by a mobile network operator at camera's location. The solution exhibits a long list of innovative features, most of which are not available in the market. That's why we believe that this innovative solution. Indicatively, it offers 24/7 monitoring of the underpasses, and this is safeguarded by the use of the ultra-low consumption battery and solar-powered wireless 4G cameras. It offers 24/7 access to cameras configuration, such as the activity detector, activation, deactivation, its sensitivity level, the control of the IR lights, etc., and to the camera's features, such as real-time video and audio streaming from a single and or multiple cameras concurrently, video and audio playback, battery usage and remaining battery percentage indication, two-way audio communication, local siren activation and deactivation upon alert, etc. It also supports automated procedures for camera snapshots uploading via Cosmotes 3G, 4G network and snapshots storage at Cosmotes cloud infrastructure. It provides real-time alerting upon movement detection to smartphones via push notification messages. And on top of that, near real-time custom presence alerts via push notification messages, including snapshots, rich messaging to smartphones upon detection of specific species, e.g. bears. It adopts innovative tools for automated detection of species passing through and automated categorization and storage of snapshots based on the species category, e.g. bears, foxes, dogs, etc., while providing tools for zero-touch statistics extraction. All this information is made available via an intuitive, user-friendly web portal. I have a snapshot. This is some information regarding the cameras that we have used in the passages. It's part of the solution. And this is, let's say, the GUI of the cameras for the configuration, the real-time streaming, the playback, etc. And this is a snapshot, sort of the web GUI, where we can see the underpasses. The green ones are the ones having the monitoring solution installed. You can see information regarding each underpass, but also you can search for a specific underpass. You can retrieve the latest images. You can have statistics on a per underpass, per day, per week, per month, per everything, and all the statistics that we will show you later regarding the usage of the underpasses. These are some also snapshots from the portal web GUI, and here there are some nice videos that we have collected from the cameras. Now, the monitoring solution is further enhanced with the so-called wildlife classification tool. Quite early in the project, we realized that a huge overhead would be required for the manual classification into species and other objects of the vast number of wildlife snapshots collected by the 45 cameras. Actually, in less than a year, we have collected about 70,000 images and 70,000 videos. Now, to extract valuable information regarding the use of the underpasses by wildlife, for example, the frequency of use per underpass and by which species, etc., the collected images shall be categorized into wildlife related, e.g. bears, foxes, reptiles, mammals, whatever, and or other objects that are irrelevant to the wildlife, for example, humans, vehicles, tractors, and false alarms. On top of that, these images must be assigned or related to a specific underpass through which the specific species passed through. This process, that is the extraction of the statistics, necessitates also a huge overhead. It is obvious that the statistics are of high importance, since they will be greatly assisting the identification of the protection, of the appropriate protection actions for animals living in the wide area of the Egnatia or Oslo infrastructure. So, to overcome the above-mentioned issues, we developed a tool, which, as I said earlier, utilizing artificial intelligence and deep learning techniques. It processes in an automated way the snapshots collected by the installed cameras. It detects, it identifies the object, bear, fox, person, whatever, with high accuracy, and finally saves the snapshot to a dedicated folder for further processing, minimizing thus the manual classification effort. Okay, this is the tool operation. The tool operates as follows. The first phase is the dataset collection phase. During this phase, hundreds of images, the so-called dataset, of the specific species or objects of interest shall be collected in order to fit the training model, which is the learning algorithm, and this is phase 2. During this phase, we train the selected algorithm to evaluate and remember an image by creating a model that can then be applied to other new images, that is transferring the characteristics from one image to another algorithmically. During the next phase, the model's effectiveness evaluation phase, we assess the model's operation using sample new images. If the accuracy is satisfactory, we proceed to the next step, which is the model running. During this phase, we utilize the model for making predictions, detection and classification, and the model is fed by the new snapshots and videos collected by the cameras. And if a satisfactory level of accuracy is achieved, it stores the result, the snapshot to the corresponding dedicated folder. Otherwise, if the result is not considered accurate, these snapshots are stored separately. Finally, during the fifth phase, this is the phase for improving the model accuracy. We can retrain the model by adding additional images to the initial or the previous dataset. And it is obvious that the more photos feeding the model, the higher the accuracy is. Note that this model can be used for the identification and classification of any custom model object, not only wildlife. However, species classification is not an easy task. Actually, there are lots of factors that are hindering the classification of the wildlife. For example, the majority of the species snapshots are night shots mainly. That is, the snapshots or images collected by the cameras are of low quality, they are blurred, they're not crispy, etc. In addition, more than one known object that need to be identified may be present in a certain snapshot. For example, when we have sheep and dogs, or sheep and humans, or humans and dogs. in the same snapshot. There are only a few images of some species, e.g. deers or wild boars, that are available, and as such, the available dataset is not adequate to feed the model properly in order to have, let's say, accurate project estimations. Also, there are also other difficulties in species detection classification. For example, in cases when the species are partly presented, for example, they are behind the vegetation. Let's see some indicative results that we have achieved. We may identify bears with accuracy more than 80%, dogs with accuracy more than 90%, sheep with accuracy more than 95%, foxes about 70%, skunks 60%, humans and persons, whatever, 100% almost, cars, a very high accuracy, and tractors, and landscape snapshots, that is no wildlife is available. This is due, let's say, to the wind or false alerts or things like this, more than 80%. And also there are these non-identifiable, let's say, objects that are not detected cannot be recognized by the model. They are stored in a separate, let's say, as a separate category. As I said earlier, the accuracy of the model can be improved by retraining it with an enriched set of images per category. The next, the zero-touch statistics. As mentioned earlier, we have collected almost 70,000 images, and these images can be categorized both on a per species object and on a per underpass basis. The tool that we have developed to facilitate this process not only extracts the statistics mentioned above with a click of a button, but also enables their visualization through the web portal in an automated way. Indicative plots, statistics that are generated automated, as I said earlier, are presented in this and the following slide. In this slide, we may see which underpasses were used and how often by the species. In our case, by bears and foxes. In the link below, you may find all the relevant info for all species. I don't know if I can click on, no, it's not clickable. Okay. In the next slide, we may see which species and how often used a specific underpass. And in this slide, we present the statistics for the underpass with code name, let's say, K59 and K69. But for all underpasses, you may click on this web link. Okay. Finally, the solution has the capability to send enriched push notification messages to smartphone users upon the detection of a specific species, such as a bear. And this is an indicative example of such a push notification message delivered at a smartphone for K69 underpass. This is the entrance, the A, and the B is the other side, the exit. The exit. Okay. To conclude, the solution that we have developed is an environmental friendly solution since it utilizes solar panels for powering the cameras. It eliminates also the need for on-site visits for material collection from the camera's SD card, because this is done automatically upon activation of the activity sensor. And this reduction reaches the 95%. It also minimizes the painstaking and time-consuming tasks related to the processing of the huge amount of photos and videos, a reduction of the order of 80%, and the exporting of the statistical data and the charts I showed you earlier, which estimate a reduction of 90%. It also combines low cost with the ease of installation, and more importantly, it is an expandable and usable solution in any country, since all you need is a 3G, 4G camera with a SIM card and a solar panel. That's all from my side, and thank you very much for your attention. I will be happy to answer to your questions, if any.
Thank you very much, Dr. Limberopoulos, for this very clear presentation and the very interesting solution. We are really tight on time. We have room for just one question. So yes, Savas.
Yes, thank you, Vasilis. Mr. EnVeROS, I will be very, very quick since time is running out. Regarding the devices you presented, I have seen a very large amount of pictures taken that you use in this this system for identifying automatically the animals. I was wondering if the pictures that you took was perhaps you said it, but I haven't heard it. There were one picture per animal per passing, or there were several pictures. I will assume that there will be several pictures. And the second question was whether this was done manually while fitting the system initially. Thank you.
Thank you very much for the question. In the training phase, you need hundreds of snapshots per object. Not one, but hundreds of them. And the model better performs if the surrounding is the same, and not, let's say, if you want to collect snapshots from bears, it would be better if these snapshots are related to the underpasses under study and not bears in the countryside or whatever, or polar bears or things like this.
Yes, of course, understood. Thank you.
Thank you very much. We are moving to close this session with Dr. Michael Bill, who is also participating in the EnVeROS project. He is a geographer. He works in the Transport Research Center in Czech Republic. His primary areas of research interest are spatial analysis of traffic crashes, animal vehicle collisions and vulnerable road users, natural hazards in relation to transport infrastructure resilience and vulnerability. Dr. Bill, you can start your presentation.
Thank you, Vasilis, and hello everyone from Olomouc. So let's talk about roadkill monitoring and roadkill issue in Czech Republic. The roadkill issue in the Czech Republic is caused by many factors. One of them is a quite dense road network, as well as a railway network, ranks among the densest in Europe. We also don't have any systematic approach related to mitigating and preventing these crashes. Majority of old highways don't have fences, for example. Also, there are a large number of huntable species, roe deer and wild boar. And roe deer alone are approximately 80% records in crash databases. But there are also other species, small animals, small mammals, birds, and amphibians, and their numbers are strongly unreported. And of course, there are also endangered species like lynx, wolf, and bears. So this is how Czech roads look like. As I said, old highways have no fences, so there is an open landscape with almost no barriers. Then, as the road network is dense and area of the Czech Republic is covered by forest, almost 30% of the area is forested, so many roads go through or along roads. And finally, many roads has trees. So if there is a conflict with an animal and the driver is trying to avoid a crash, then they can lose control and collide with a tree, and these collisions are very often fatal. Concerning the roadkill and the question how we monitor the roadkill, the most important source of data we have comes from police. Czech police records traffic crashes. This means that such events are only those when there is some damage or injury. It means that the majority of these events are crashes with ungulates. Then there are also some citizen science initiatives. For example, birds.cz, which is a bird watching application. And also Nature Conservation Agency of the Czech Republic has its own biolog application. To both these applications, volunteers add observations of animals, and some of them also add observation of dead animals. And the last data source are some ad hoc campaigns, which are time and spatially projects, for example, parts of diploma theses and some research projects. So this is why we developed 6 years ago a reporting application called sraženazvěř.cz, and our aim was to concentrate as many as possible sources of roadkill and wildlife vehicle collisions at one place. And this application is intended not only for general public and environmentalists, but also for drivers, as it shows dangerous places where crashes with ungulates concentrate. 3 years ago, we published a paper about this application, so more information is there. How do data vary from different sources in this application? As you can see, the majority of data to Sraženazvěř come from police. These data are crashes, traffic crashes with animals. Approximately 20% of data are data which can be called as citizen science data, and they come from the volunteers and from hunters. Records in this database also differs in terms of animal size. Logically, police records mammals, ungulates, whereas volunteers are more focused on smaller animals like amphibians, reptiles, and birds. The important question is when do roadkill occur? We prepared on the basis of actual data such an animation. You can click on the link below to launch the animation, and there you can see the dependence of the number of crashes on the sun head and the time of the year and a day. This animation is being used in educational purposes as well. We can draw such graphs from our data. On the left side, you can see for wild boar, on the right side from roe deer. And if you have a precise data, that means that they have also a precise time of crash. You can see that crashes with wild boar concentrate during winter and autumn and late autumn in night, whereas the peak of crashes with roe deer is approximately 1 hour after sunset during May. Question is how to identify these places, because it is important to distinguish between hotspots and false hotspots, and therefore we developed a method. It was already mentioned here during this webinar. On this side, on this picture on the left, you can see 2 clusters. It means that if you apply clustering method, the result is always a cluster. Then it is necessary to distinguish which of the cluster is a real hotspots and which is only a statistical noise. Then we apply so-called KDE method, which is based on multiple Monte Carlo simulations, and we are able to set this red line, which distinguishes between the real hotspot and the noise. And the real hotspots are then called as these clusters. Significant clusters are then called as hotspots. And we also developed a software. So just go to this site, kde+.cz, and you can download this software for both ArcGIS as a toolbox and as a standalone application. There are only 2 input data files, data on row network and data on crashes. And you obtain a shapefile with hotspots. But we can also proceed with analysis of hotspots in order to identify factors which induced the hotspots occurrence, as this is important for both mitigation and for identification of potentially dangerous locations. In these 2 works, which are here, we found, for example, that the distance to forests up to 150 meters was a strong predictor of hotspots occurrence. In another publication, in another work, we found that quality of food source near a road was also an important predictor of emergence of hotspots. So it is important to cut trees and all sources of food which can attract animals close to road. Another problem with data is that many databases are not complete. This is a well-known issue with many data, not only crash data. So how to proceed? We try to simulate the effect of underreporting. It means that we randomly removed data from our database and we observed the results. Here on the left side, you can see one artificial road, 2 kilometers long, with 4 hotspots. In this example, there is no underreporting. And if we randomly remove 20% of data, then the 2 strongest hotspots still remain, whereas the 2 smaller ones are almost not there. And if we go further to, for example, 60% of underreporting, then only the 2 strongest hotspots remain detectable. This means that if you analyze data and if you obtain hotspots, then you should start working with the strongest ones. And then there is another possibility how to work with hotspots. As usually there are databases covering more years, you can also observe hotspots evolution over time. For such a task, we suggest spatial temporal graphs. On the right side, you can see an example of such a graph. On the x-axis, you can see length of a road. On y-axis, you can see time. If there is a hotspot, you can observe its evolution. In this particular case, the hotspot was stable over the entire time. So it means that it's a really dangerous place. This approach is capable to not only to determine stable hotspots, but also hotspots which disappeared. It means that some mitigation measure was successfully applied, or opposite situation when there was a problem. So from some time, crashes started to appear and in a road, and there is a good idea to go to the field and to inspect what went wrong there. The question is which mitigation measures we should apply to hotspots. We have already seen that there are some measures for highways, such as fences together with over or underpasses. But in Czech Republic, it's very frequently used mitigation measure called odor repellent. We analyzed the effectiveness of these measures, and we received not only positive results. In one research, we analyzed roadkill data, and we found that if these odor repellents are properly applied, then you can achieve the decrease of roadkill up to 43%. But in the more recent analysis, we analyzed the behavior of ungulates, behavior of road deer near roads, and in this case we found no effect of these measures on their behavior. Then it is also important to monitor not only roadkill and dangerous places based on analysis of roadkill, but also movement of animals, which is important, for example, for determination of places where animals cross roads. In the same research, we had 10 road deer equipped with GPS collars, and we determined places where these road deer crossed the roads. So this is a useful way how to find these places, which can be compared with hotspots. Here is just a comparison. We already applied this KDA Plus method for hotspot determination to check data to both roads and also railways, as also railway or rail tracks are places where crashes with animals occur. And we found interesting statistics that the large portion of these events, for example, 40% for railways and approximately 30% for roads, are occurring on very short parts of both networks, approximately 1% of length and less. And this is important message for road and railway administrators, that problems are concentrate to these very short stretches of transportation infrastructure. So these are places where their mitigation effort should be applied, should be targeting. And here is some comparison of evolution of data, of crash data for both roads and railways. As you can see, the time series for the last 10 years are still increasing. There's increasing trend for vital vehicle collisions in both roads and railways. And on the right side, you can see a comparison with regard to species involved. As you can see, ungulates and the roe deer and wild boar in particular are the most involved species in this kind of crashes. So thank you very much for attention.
Thank you very much, Mikael, for this very interesting presentation. We are just on time. We have room for one question to Mikael, and then we will proceed to close this session and the whole webinar. So are there any questions? There is one question from Fabian. Did you see any overlap between the KD plus hotspots and the roe deer GPS movement data?
No, at the moment, because the work I presented right now was conducted on one road. This means that we only had a limited number of roadkill. But from the next January, we will start with a 3-year project during which we will have a high number of collared animals, roe deer and wild boar, and also the area of the study will be larger. So it will be possible to compare roadkill hotspots and the places of the most frequent road crossings.
Thank you, Mikael. There is one more question from Ioannis. How does KDE plus method differs from other spatial techniques used for hotspot ID. And let me tell the participants that we have opened the microphones for a general discussion.
So, thank you, Giannis, for your question. We compared the method with our first paper, 2013, to other methods, and the main difference, there were two principal differences. The first one was that the typical KDE method, for example, the built-in method, which is in ArcGIS, only produces hotspots, but there is no way, no tool how to say which of the clusters are hotspots. It means which are statistically significant, and which of them are only the random. So the first difference is that KDE Plus sets such a threshold. And if you have thresholds, you can also measure the difference of the vertical difference of the top of the hotspots to this threshold. That means that you can provide this number. We call it as a cluster strength. And on the basis of this cluster strength, you are able to rank the hotspots. So these two features are where the method differs from others.
Thank you, Mikhail. Are there any other comments, questions? Not only to Mikhail, to the other presenters. You can raise your hand, and you have a microphone if you prefer. Yes, Ioannis? Ioannis has a question for Dr. Liberopoulos. In the graphs frequency of use for underpasses, have you examined further why are some more used than others?
I assume that this is due to the characteristics of the underpass, how wide it is, whether there are obstacles, things like this. That's why we need to perform some improvements in or interventions in the underpasses to facilitate passing through of the animals.
Ioannis says, so it's the technical characteristics, I assume.
Not only, but actually we don't know because we have just, let's say, processed the snapshots. We don't know, let's say, the surroundings, the actual location of the underpasses, the main roads, passages, whether there are trees or forests in the vicinity. We actually don't know the surroundings, the environment. So, yeah. Our colleagues from Callisto, for sure, they know much much more information on the underpasses characteristics, and they have evaluated the area and the mobility of the animals.
Thank you very much. We have a question from Yorgos Merzanis. Yes, please. You have
yes. Good evening. Thank you for giving me the floor. Congratulations for the organization and for the quality of the presentations. Some comments I have, just what my dear colleague Yorgos Liberopoulos said before, because we are cooperating in this big venture with underpass monitoring. I'm working for the NGO Callisto, and we are partners in this Life Safe Crossing project. So the whole camera issue addresses, targets the brown bear, which is the species that Mrs. Mertens mentioned before. So we are now examining the main reasons why the bears get attracted by specific structures and not by others. So far, among the 45 monitored by cameras, the 36 of them were preferred by bears, but the preferential use was even more emphasized for specific types of underpasses, which are mostly culverts and also underpasses. So we are now examining three key factors: the openness index, which is the combination of the width, the length, and the height of the entrances, the visibility that the animal has throughout the whole crossing structure, and the third is the vegetation coverage at the microhabitat scale. And we are going to try to connect it to the macrohabitat connectivity scale aspect. So we're now we're doing some statistics, and we are going to present that at the ENE conference workshop next January, hopefully. So indeed, there are some more specific factors probably attracting and making the animals to choose, especially the birds, to choose these types of infrastructures instead of others. Thank you.
Thank you very much, Mr. Merzanis. Any other comments? Well, if we don't have anything else, I would like to thank the presenters in the today's two sessions. It was a real pleasure for us to have you here. Of course, we have planned to have you face to face, but yeah, the situation with the COVID kind of forced us to go to this webinar. I will give the floor to the coordinator of the EnVeROS project, Professor Giannis Voghiatzakis.
Thank you, Vasil. Thank you very much, and good afternoon again to everyone. It's been a long session. It's been a long day. Let me turn on my camera as well. It's been very interesting to find out what each one of you is doing. As Vasilis mentioned earlier on, the idea was to have all of you, or most of you, in Cyprus, but this was not possible. We have been engaged at the Open University of Cyprus in the Terrestrial Ecosystem Management Lab, which I coordinate. We have been engaged with road ecology related research since 2014. For us, it's a pleasure to see all these new evolving techniques. It was a pleasure to have every single one of you, and I'm not just talking about the speakers who really like to thank, but also the audience as well, some of who I know, and I know what they're doing, and I hope that they have found these 2-day sessions interesting. And of course, to me, it's really encouraging to see this ever-expanding community, if you want, of people working around the issue of road ecology, roadkills, monitoring of wildlife, and the interface with the linear infrastructure. That's how Wendy Connaughton called it earlier this afternoon. It's one of the topics, as I said yesterday in my opening sort of presentation, that requires as many these days, requires the collaboration of very diverse disciplines, but your talks these 2 days and the work we've partly doing demonstrates that it's doable. It's doable, and the results are amazing. I was really impressed by the work that was presented today for environmental monitoring citizen science by Helen Rowe. Of course, I know the work that's been done in Cyprus by the BirdLife and the Cyprus monitoring group, and I was amazed to see the results from Life Strada and Life's Safe Crossing. Dr. Mertens, the work on wildlife mortality by Dr. Russell, the data sets and the setting, the technical part that was presented by Dr. Liberopoulos from Cosmote. For someone who doesn't know much about this sort of technology and the science behind it, it's really impressive. It's really impressive. And of course, last but not least, and I highlighted that yesterday, but I would like to say it again today. I was impressed the first time I read about the monitoring of animal vehicle collisions system that was in place in Czech Republic, and I think that Dr. Bill and his team is to be congratulated for this huge effort all over this year, because for many aspects of this topic, they're actually leading the way, and that's showing us how things should be done properly in a consistent manner, both technically, if you want, but also on the applied side, on the use of this data to form evidence-based conservation. So I would not like to add anything more than that. EnVeROS has come into a full cycle after 2 years and almost 3 months, and it has certainly opened up, to my mind at least, as it's usually the case, new avenues and new questions rather than solving or answering old ones. And I would like to close the session with a wish that, in addition to IAEA, we will get the chance to actually collaborate in the near future towards this common goal, towards bringing, if you want, citizen science into road ecology and environmental protection, species conservation. So once again, thank you so much for your time, for your effort. Thank you for this a successful and well-attended event. And let's hope we'll meet up pretty soon when COVID is gone, and we'll be able to shake hands and over a glass of wine or a pint of beer and exchange ideas and about nature conservation and how we can best approach the milestone that is set by the European Union to 2030 for halting biodiversity loss. Thank you so much. Have a great evening and stay safe.
Thank you very much. Bye. Bye to everyone.
Thank you all. Bye.
Bye.
Good night, everyone.
Thank you very much for everything. Compliments for this great webinar.
Thank you very much.
Bye.
Bye. Thank you very much. Bye.
Bye.